Let me start recording. Okay. So, all right. So last time what we discussed was that how to use, not only discuss, but we did a hands-on. It was like group coding exercise where we built a end-to-end word recommender using using. So in our previous session, what we have built was we have built a word recommender in around 1 hour time, maybe a little more than 1 hour time, and using Python and using MapReduce. Word recommender is something if you basically we built a dictionary of word and the next word recommendations. Okay, so that way we basically gave top 5 words recommendation, and that all of it we did it in Python. The idea was to give you a boost that using a Python, such kind of work are more of a pleasure than the core chore, whatever you call it. So was that helpful to you? That exercise?
Yes.
Okay. Okay. Because these are minor little experiments. I'm just trying to figure out what is the best way to learn a programming language. Okay. Because there are books, there are so many other things to learn. There are so many videos all across internet, but all of those are there, but we are not able to focus and learn properly using any of those techniques. So what I found is that one, doing it in live session the way we did it earlier, meaning you all are writing a small little program, gives you more confidence that in next time if you happen to look at the code, it does not, it will be more friendly to you. Second is that if somebody asks you that how much time do you think this kind of work will take, your estimation will improve as you look at more code, as you do some things, that estimation will improve. And if the estimation improves, then that means then there'll be less inertia to work on code. Because with programming, the biggest challenge is the developer's mindset. If the developer is not comfortable with the programming language, the output is bad, it takes long time, and the output is also buggy. All right, and that applies to anybody who does work in software engineering. That if there is a fear of typing too much, then we would avoid a technology subconsciously. All right. So that is the one reason why Python has been fairly successful, because typing work is not too much. Okay. So first, if something is slow with respect to if you are running something, if taking too much time to load, too much time to compile, then you will have inertia to use it. You will avoid it. Second, if something has no reward and punishment mechanism immediate, the more immediate feedback you get, the more you like it. That is the difference between playing a game and doing some activity. When you play a game, you get the feedback immediately, and that's why you like it generally. And if you are doing some activity of which the output will come 2 days later, then you will not enjoy that activity. So therefore, in all of these circumstances, first, typing less. Second, uh, getting things easier done. Third, immediate feedback. In all of these, the Python and the way we have been trying to get our class organized should be helpful. Okay. So so now I think everybody can write at least a basic program, right? Okay. So before coming to the class, on the way to the class, I was able to quickly code our stocks example. You can see that. Right. So can anybody tell me what is the complexity of this code? How many number of steps will be executed approximately? If there are n stocks, how many times this loop will run? N number of times, right? If you were searching again and again, your number of steps would have been n square. Say you pick up one value, go searching for maximum, pick up another, go searching for a maximum, then pick up another, go searching for maximum. If you do that, then if you do that, then the total time would have been n square. Okay. So if there are stock prices of thousands, okay, thousand, and one comparison is taking 1 millisecond, then the in this program will take 1000 millisecond, which is 1 second, while the other program will take uh, 1 million milliseconds, okay, which is 1000 second, and which is how much? 1000 divided by 60 is 100 divided by 60, 50 divided by 30, 17. 17, around 17 minutes. While one program is taking 1 second, other program will take 16 minutes. And this difference will keep on rising as we go forward. If we have, say, our one program is taking, say, 10,000 steps, say 10,000 stocks are there. Okay. So let's say each step is taking 1 millisecond time. So one program will take 10 seconds and other program might take few hours. Okay. So 10,000, the square of 10,000 is how much? Mm, 10 to the power 8. 10 to the power 8. That many milliseconds your program will take. And 10,000, 10 to the power 8 milliseconds is equal to 10 to the power 5 seconds. And that is equivalent to how many hours? 10 to the power, I'll use Python for this. So I'm talking about 10 to the power 4. So 10 to the power 8. Okay. Now this divided by 1000, these many milliseconds, these many seconds, and divided by these many minutes, these many hours. So it'll take 27 hours. While one program is taking 10 seconds, other program is taking 27 hours. So that is the difference keeps on increasing as we keeps on going on the number. So that is the biggest difference while you are programming. Keep in mind the relationship between input and number of times anything gets executed. The relationship is more important than the individual expression. Okay. Relationship is far more important. Okay. So is this clear? Should I explain it or is it clear to everybody? So problem statement here was you are given a list of stocks. You are given a list of stocks, and what you need to do is out of those list of stocks, you have to find out the best buy and sell. Okay, you have to buy once and sell once. So what is the maximum money you can make? You have to tell that. For example, look at the last problem. So what will be the best buy and sell? Anybody looking at this number? So these are the stock price on day 0, day 1, day 2, day 3, day 4. These are the stock prices. So when should I buy? 0. And when should I sell? 15. 15. And now if I have 17 here and I say 27. So when should I buy and when should I sell? 1 and 27, right? So we are able to do it very quickly. Now, if we have to do it the same thing programmatically, then how do I do that? Or let me just increase it. Let's say this is 1 and last number is 0 and first number is 50. Okay. So now when will you buy and sell? What will be your maximum profit you will get? 26. 26. All right. So let's see if this program works fine. And also, we talked last time about what was our. So we can actually import stocks just like that, and it will work fine. Okay. But this is wrong. So the output is wrong here, isn't it? Hmm?
That is correct, right? We can't make profit
Why can't you make profit?
because the moment
You are able to. This is the stock price. So, can anybody help me find out the problems with this quickly? So, Pritpalji, you are clear about this logic, no? So, we are going from left to right. So, we first assume
26.
that the first value is our for best buy. That's the first thing. Best buy is first value, which means we are making a zero profit. So, we pick up for stock zero stock. Okay. And then we go over the range, and then run. So, but why is it giving us this problem? Let me try to run it again. Python. Yeah.
It is working for zero.
Why is it giving us zero? Can anybody help?
26 should be the answer. Right?
Yeah?
26 is fine. See, I am assuming it is because the first element itself is your min and max.
Correct.
So max is
So what is happening is the moment the first element is 50,
yeah.
it is taking new min, new max is 50, and when it is encountering a new min, which is stock is less than the new min, which is 1, it is new min has to be 1, right?
Yeah.
And as we go ahead, if we encounter that stock is greater than new max, okay, stock is greater than new max, then it has to assume that. Ideally, it should basically check if it is greater than new min. Because what will happen is it will keep checking with the new max, and it will never find out anything better than that. Hmm? Yeah. So I think
Otherwise, Sandeep, this works fine if you could make max as -1, Sandeep.
no, this will not work fine. Okay. Yeah. Now it's fine. All right. So the program is very, very simple if you look at it. Is it clear to you now? The program? You want me to explain? Okay. Jagdish? So I forgot your name.
Bobby.
Moby. Bobby. Okay, Bobby. All right. So Debashish, is this clear to you?
Not too clear.
Okay. Approach wise, is it clear to you? Approach wise.
Because I understand. Profit I understand, but
So the way we are doing is we are maintaining the max profit we could make so far in a variable. Now,
Sandeep, can you explain more?
can you put it up?
Yeah, yeah. With that. Zero.
I hope the recording is being done properly. All right. Okay, so let me try to explain it on the whiteboard. Give me a second.
Isn't it
What can
be
I
easy
do?
if we do it in reverse?
In reverse, Sachin?
Add a reverse order.
Alright. In reverse, Sachin?
You start with the same logic.
Hmm. You look up for minimum. So I'll ask you that if we have a list of numbers, if we have list of numbers, that's what I'm doing. I'm looping through the thing.
Oh goodness.
So my complexity is aware. Alright. I think I have a marker. Okay. Wow. So looks like really, really bad day. It is a new marker, man. Hmm?
People I want. You can try one day.
Okay. If I have a good day. Wow. This is awkward. Okay, this is also new. Let's see our luck. Yeah, great. This one is good. All right. So if you have numbers, say if there is a list of numbers, and you have to find maximum. Okay. So what you do is you assume initial value. That's a maximum. Then you compare it with the rest of the numbers and find out whenever you hit the best, you store it. Okay.
That we understand.
That we understand. So
Just
what we
wanted
have
to
done is we have this is our maximum beginning. This is maximum so far. Now, as and when we encounter the next number which is smaller than this. When we encounter a number which is smaller than this, we mark it as new min. Okay, this is max profit. Okay.
But Sandeep, you have initialized that new minimum is equal to stock zero, new max, both you initialize.
Yes, initially both are pointing to this. All three. So our maximum is initially new min is this and new max is this. New min and max both are same. And so profit is how much? Profit you are making is
Max minus
which is
zero.
zero. Alright. That's what we are doing here. Now we go to the next element and check if this is smaller than our first element. Meaning we are looking for next element which is smaller than our previous computed. So we assume that selling and buying on the first element giving us the best one. Now next element, as soon as we encounter if this number is is lesser than what we already assumed, that means there are chances that we will hit a better one.
So that is line number 8, 9, and 10.
So so the moment we hit a stock which is smaller than our previous value, that means there are chances that somewhere down the line we might get a better profit than this. Okay? Because if this number is bigger than what we had earlier, or the other case could be our new number stock price is better than previous value. Max is bigger than the previous value. So maybe instead of this range, right now this is our range, right? Maybe our best range is this. Sell here, buy here, sell here. Okay. Or on the new value, maybe we buy here and maybe in future we might sell. Okay. That's why I've said my new min becomes the stock price the moment we hit the new min. But we are not changing best so far. Best so far is still 0. Okay. Best so far is still 0 because we don't know. Make sense, no? Rakesh?
Yeah.
And the moment we hit another stock price which is better than our max, which is better than this value, that means that our range might increase. You getting me?
Yes.
So whenever we are examining a stock price, what would happen is either this new stock price is starting of the better side, or okay. Let me explain. Okay, so if the current stock price is better than our maximum, so which is maximum is this. Initially, our maximum is this. If our number is better than this one, which means that our new maximum will be this stock price, and hence our this profit would be new max minus new min. And if this profit is better than best so far, then we update our best so far. Okay. So we are examining new two numbers. We are figuring out new range. We have already computed a overall profit. Okay. We have already computed an overall profit. And the moment we hit a better profit than that one, we will update it. As we go ahead, as and when we encounter a better profit than the previous one, we'll update it. Devashish? Makes sense to you?
According to those numbers.
These numbers, yeah, that is, I think, a better idea. I'll show you. So let's start with these numbers. Okay. So when 50 is encountered, in the first stage, all right. So the moment, so let's say new min, new max, and best so far. Okay, these are the three numbers. In the 0th stage, okay, in the 0th stage, this is 50, this is 50, and this is 0. Right? Or let me just say profit. Okay.
So, Sandeep, one question here. Like we are doing analysis, right? Like it cannot be on a current date, right?
It is not current data. This is the past data.
Past analysis.
Past data. Yeah. Yeah. So some algorithm claims that they made a maximum profit. Some algorithm claims that they made the maximum profit for you. Now you want to analyze that did they really make a better profit for you, or is there any other way to do that? Okay. Alright. So NM new max min max profit. Okay. Is it visible to you? Min max profit. So initially 50 50 0. The moment we encounter 1, what will happen is the moment we encounter 1 is lesser than minimum. So our minimum will become 1, new minimum. Okay. Maxima will stay 50. Okay. No, new maxima will also become 1. See this?
Even without that statement, it is written in 26.
And the profit will remain 0 as is. What?
Even that new max, we added new statement.
Right.
even without that statement,
No, if you remove 50 from here, right, then that will give error.
So on the day one, we are saying that
Now the day 2,
yeah.
now the day 2, which is 3, now we encountered 3. Is 3 lesser than our minimum? So 3 should start a new range or add to the range. Okay. So minimum will remain 1, but maximum will become 3. This is the new range we are talking about. Okay. Now the difference is 2, which is better than 0, right?
Yeah.
That is where we will update our. Make sense? Now we
So now-
encounter another variable. Its value is 4. 4. Now 4 is better than max. Min will remain same. 4 will increase our range starting from 1 to 4. And so our profit will become 3, which is better than 2. So it will update that. Now, the moment we encounter 27, the fourth index, 27 is better than our max, but minimum will remain same. Okay? And the profit is 26. Now, fifth element, which is 1, 1. Okay? Now, fifth element is 1. So, it is not less than our minimum. It is not greater than our maximum. So, these will remain as such. Okay?
Eligibility goes to better maximum value.
Right, right. So, or you can plot it on the graph saying this is your 50, this is your 1, this is your 3, this is your 4, this is your 27, this is your 1, this is your 1, and this is your, say, 4 and 27, right? So 9 will be somewhere here, and then this is again your 1, and 15 will be somewhere here, and then 0.
So
Okay.
now
So this is our plot. No, sorry, here.
So Sandeep, if you see this, then considering like the day of 0, like that is the first day of the year or something, whatever you calculate. Right? You, let's assume you bought the shares at 50 rupees.
Right.
Okay. So the profit, the max also at 150 rupees. So your base investment is 50 rupees. Right? So the next day the share price is 1 rupee. That's what you are saying, right?
Yeah.
So if you see that you had a
Loss.
loss of 49 rupees then.
Yes.
On the day 2.
Yeah.
And day 3, if it is still 1 and day 3 it is 3 rupees.
So if you bought at 50, right, you made a loss.
Yeah.
Here we are analyzing. Say there is a one guy who told you that we have made the maximum profit for you, and you come around and do the computation and say, you know what? If you could have bought at 1 and sold at 27, that would have been best profit for me, not what you're claiming. Okay. So this is your, after everything is over, you have this luxury of going through numbers, and you are going through those numbers and analyzing it. So now it's clear?
Yes.
So now going further, now fifth element is 1. Fifth element, this is 0, 1, 2, 3, 4, 5. Now sixth element, which is 9. Now in case of a 9, we can say 9 is neither lesser than min nor bigger than max. Therefore 9 is out of the picture. There is no point in considering 9. Because neither it will increase, neither it will start me a next minima, nor it will give me a better profit. Okay, right? In any case, 9 cannot be included in my overall thing. Okay, and therefore this will remain as such. Now seventh element, which is 1, 1 is not less than my minimum, and it will remain 26. 15. So neither 15, which is not going is neither less than smaller or this thing. Now the 0, 1, what will happen at 0 is our minima will update to 0. Our minima will update to 0, but maxima will remain 27. maxima is still 27. And what will happen here if the maxima is still 27? That we will differentiate. Sorry, this will also become our 0, right? If it is lesser than the new minimum. So this has minima has min has new minimum has become 0, new maxima has become 0. So the profit is 0 yet. Therefore, we will not update our actual value. Yeah? Correct? So then it will remain 26. So we make a profit of 26. Now, if we had to report that on what date should I buy and on what date should I sell, then we had to store both indexes. Correct? We had to keep storing the indexes as well. We have not stored the indexes. All right. So this is a simple exercise. Looks a very simple code, but these kind of exercise would happen all the time. It's just that you need to be up and running and should be able to build a quick prototype using your code. All right.
Can you share this?
It's shared. It's in that folder called examples. All right. Any questions at this point? No questions. Okay. So the question which we left with on Friday, did anybody try any other method of that? No. But what was the question? Do you even remember?
That's all.
Okay. The question is that the problem. What was the problem we did on Friday?
Word by top 5.
Top 5. Correct. So out of that, we discussed that there was problems in that, and the problem was
Problem is after that we need to have a space and then consider as a
okay. Okay, that is
Underline.
one. What was the other one? The other problem was computing top 5 for words who are very frequently occurring.
That
Is, am, are will have lot of words following them, and you can imagine the words like a or the. There are so many words that follow these words, and computing top 5 should actually be further map read, right? Computing top 5 should be a map reduce exercise, not this way. So that has to be thought through. Okay, and these are all. This is where most of the people get actually stuck when they try to solve big data problem, and they get stuck saying, Python is very slow because we are not able to compute top 5. It's not Python is not slow, it's just that your algorithm is bad. Okay. I remember a little while back, so when I was building recommender for InMobi, so I wrote code in Python. In Python, the dictionary takes amount 4 times the actual space. Okay. If you have the data stored in a dictionary, which is of say 100 MB, Python will consume 400 MB. And this way, my program was consuming around 4 GB data, 4 GB RAM, which was not permitted. Okay. And the reason was simple, that I was relying on in-memory computing rather than further doing MapReduce. Like the way we were computing top 5, the top 5 is going to kill your machine if those values are huge. When we are doing top 5 computation, right? What we are doing? We're creating an array, creating a dictionary, and then computing, sorting it. So if that array is huge, say beyond few, say 10 GB, beyond 10 GB, then that is not going to be acceptable by MapReduce. Reason being, MapReduce does not give you that much of memory for each reduced task. Okay, and therefore you'll have to figure out strategies. One of the common strategies would be, first form the key by first word dash second word. Okay, that will be your key, and count how many times it's occurring. So this way, instead of you taking the load of sorting and computing, you delegated the headache to MapReduce. Okay. So you need to be cautious about how you are performing things. Okay. I'll show you that same code which we were talking about yesterday. So where is that MapReduce? I think I was doing it on the machine, but I've copied it. And do you see somewhere? MapReduce, yeah. All right. So looks familiar?
So for each word, key and value, make it one word and count frequency.
Correct. So in Mapper, in Mapper, what we did was in Mapper, what we did was all right. So all right. Now here, what is the text clear to you? All right. So this looks very innocent piece of code, right? But this part, if you look at the reducer, what we are doing here, look at this. Everywhere we are creating a dictionary, new dictionary. One dictionary, second array, third array, right? Third array is smaller, just 5 elements. Okay. But these two are going to kill your RAM. If your data is say 2 GB in words, 2 actual GB means the strings, the text is 2 GB. So what will happen here is 2 into 4 is 8 and plus 8 is 16 GB. So it's going to consume a lot of time.
So the first dictionary, instead of writing in dictionary, we again output in the file.
No.
Yeah, that is one way.
Yeah. See, other thing is combine two words. Right?
That's
what basically. Ultimately.
So you have to
user
find,
recommendation.
if you can find the frequencies of two pairs occurring, okay, using MapReduce, how frequently these two pairs are occurring, and do that for all the pairs. So in your map function, instead of making key as first word, value as
Here
second
only
word,
we concatenate.
what you do is you make the first word dash second word as the key and then compute it, right? And that way you can do the computation of each word and then do a second phase of MapReduce. So effectively, you will be able to do it faster in a small amount of memory and done. So I was telling you, one of my students sent me an R program to compute the same thing. It was his master's project. And when I looked at it, I asked him, like, after how many records did it flunk? He said, after 1 GB, we could not go ahead because it took so much of RAM and we did not have so much of money to buy RAM. And our laptops did not support that kind of RAM. Maybe we would have used a supercomputer to get it done. I said, can you do that in so my whole agenda was to tell that the whole MapReduce process is designed in a way that you can solve such kind of problems distributedly. Okay, so that's where the whole MapReduce and everything comes into play when you get stuck with the memory issues. So also, as you are saying that you could have used a file, that's also one approach. That's also one approach. But imagine you yourself doing that. Imagine doing that for each key in the dictionary. Okay. So that could have been a little bit more horrible. So all the sorting tasks you generally leave to MapReduce Hadoop, and rest things you take care of. And the trick is to figure out how can you MapReduce. The trick is to find out how can you use MapReduce.
But solving this traditional problems, start price, whatever, those kind of algorithms are different than
So whenever
distributed problem solving. Needed new thinking of
new
algorithms.
thinking, yes, it requires you to think through. Every time I look at a problem, I have a tough time to figure out how can I convert a problem into a MapReduce. For example, if I ask Pritpal sir that how would you compute median of 100 billion numbers using MapReduce, how will you do that? Median of 100 billion numbers.
Yeah. So again, we'll have to maybe take.
Computing median was a very small exercise, right? All you have to do is if total number are even, then you pick up the middle one.
N plus
If the total numbers are odd, you just
n minus 1.
so if they are even, pick the middle two,
Yeah.
average them. If it is odd, you can pick the median. So that's how you compute it, median. The question is,
Within a distributed environment.
how can you do that using distributed environment?
For reduce, it comes already sorted, right?
That's fine, but
For-
how
So
will
in
you
reduce,
how will you do it in a distributed one?
How would you do it in MapReduce? Yeah,
There will be 2 cycles.
2 cycles. Yes, go ahead. Yeah,
So map and reduce.
okay.
So let's say we get from 100, whatever 10 billion, we get a small subset. You again combine them, again reduce.
Okay. No, I didn't get it.
median.
Median of medians is not
Not
correct.
a median.
Not a median.
No, it's not a median.
Yeah.
Then,
Okay. No. So if you remember, so that's where the innovativeness lies on a developer part. So if you remember, we talked about something called input split, and in MapReduce we get the byte count and each line. So we need to modify our input split so that we get line number instead of byte count. First step. Second step would be to write first page of map to count numbers. That's all. Do the count of numbers. That's all. Okay.
Instead of doing that, you can do it in a different way, right?
Hmm.
Suppose there is a bunch of numbers
Yeah.
and you need to find the middle number.
Bunch of numbers. You have to find the middle number. Okay.
Yeah. So you arrange the numbers like from the lower to the highest and find the middle number and
Yeah. So you assume. My question is there are 200 billion numbers.
So
200
we
billion
already know
numbers.
the count, right?
To approximately 200 billion numbers. Okay.
But the last block of the file will give me the total number, right? Why we need
No,
to again
no,
for
no,
count, we
how-
need to
how
do
would you
map,
know?
right?
yeah. No. Where did you get that?
If numbers are
No, it will give you the size of the file, not the number of total number of numbers, right?
each line one number, right?
Yeah, so that does not mean the file size is dictated by the number. Each number has got different set of digits. Okay? So the way it's stored in memory is not equal to the way it is stored in disk.
But there's no way to get the last file and see how many lines.
So I mean the only thing you will get is the total number of size. And what does it mean by line number? Tell me, what does it mean by line?
No, for example,
If you
this
look at the
file,
binary
100 lines
perspective,
Huh?
if you look at the binary perspective, line means something after slash n, right? This, if the moment you encounter this special character called slash n, we start counting, saying line, right? So from the file's perspective, it doesn't matter how many lines. So they don't track that line numbers. Okay. So that's why it only gives you the byte count as well. That's the same reasoning why MapReduce gives you byte count, not the line number. So you'll have to write first input split, which gives you line number. Second, you will have to second thing you'll have to do is in first phase count total number of letters, total number of numbers, count it, and then in the second phase, once you have found out how many total number are there, you keep on skipping those numbers which are not middle, and that's all. Don't print any key value for them. That is one way. Okay.
But you have to sort them out, right? First.
Yeah, let's
And
assume
then-
that they are
That
sorted.
is simple.
Oh, they are sorted.
Let's assume they're sorted is okay. Everybody sorts the numbers. So that way you can basically do that.
In
So-
reduce, what we input we get for each
For each line, we will not have any reduce per se. Or maybe in reduce we just have, if there is a single value, don't generate any number. Okay, just print out if there are two values, print average of those. Find it? So in the map, we'll only give two numbers as the output,
Line
and
number
that
and the number.
yeah, that too based on if the line number is half of the actual number, only then we give out any key value. Otherwise, we keep on skipping everything. So this is a little this way. I mean, it's very difficult to code these kind of things. So
Can't that reduce function for those many lines, right?
yeah.
When each line is
No, if
calculated,
there is no key value, right? No key value coming from the map side, there will be no reduce execution, right?
So this sorting happens after map.
Yeah.
So we are assuming that the first sort when we have line number and the number, the sorted output is already there.
Yeah. Yeah. All right, makes sense to you? No. So the simple idea about why I'm asking this question is whenever you encounter a problem, you need to think through how can you make it parallel. And there are a lot of problems such as finding Fibonacci series or solving this problem which we just did. The problem we just solved is actually pretty difficult to solve using MapReduce. It's fairly difficult. All right, sounds good to you? So, all right. So now I'm going to proceed with the rest of the stuff. Don't tell me it is gone again. Okay, so here we are, and we have what? So we were talking about this one. All right. Now next is how to do pig UDF using Python. So MapReduce in Python we have done already using streaming. Now, so some people did realize that. So what is pig? You remember? No. You remember what was pig?
It was basically a scripting language through which we used to, extract values, or in case, we can extract the values which is there in the SDFS.
Correct. Correct. Yes. So yes. So basically, it is a scripting language with which you can manipulate data in our or analyze data which is lying in SPFS or any other thing, and anything you do in Pig gets converted internally in MapReduce. So you don't have to fiddle around with MapReduces. You instead think in terms of filter, group by, order by, join this with that, and all that. Way. Sort of a data analyzer's point of view. Okay, so it's more or less like a SQL for big data, and it works really good. It really works smooth. Now, when we are dealing with pig, there will be many circumstances when you will not be able to use the pigletting. Pigletting may not suffice for you. Pigletting may not be sufficient in many circumstances, and you may want to use Python in those cases. Okay. Say for example, we have already written this complex piece of code of computing the stock prices. Now I don't want to do that using pig. Okay. Instead, I want to utilize my Python code. So we can utilize that kind of code in Pig. So whatever we have, we can use inside Pig. And how do we do that? Okay. So let's assume that we have these two functions, deposit and withdraw, and there is some balance left. And no, this is wrong. Yeah, that was wrong. This is correct one. Yeah. So here we have, imagine that we have a simple function in Python called length of the word, and all it does inside is called sum function. Okay, now let's say we want to port it to Pig. We want to run from inside of Pig our Python code. In those cases, how will you do that? First, you will have to mention the output schema, meaning the name of the column and the data type. You have to tell Pig that when I return the value, give the name as this one. So there, so that's what it does. Okay. And second is, so we start with Pig. Once we have written that piece of code, we start Pig, and then we register our lcal. This is our lcal. This is our lcal.py. And once we have written this, we will say start Pig and then say register lcal.py using Jython as a lcal, and then load your data using say a equals to load words.txt. And once that is done, we can say ll equals to for each a generate lcal.length. Sounds good? So basically, lcal object is what is representing your lcal.py, and all the functions we have mentioned in this file are available here. Okay, and then we can save them. So this is Pig script.
So there we use the annotation, right?
Yes. Yeah, annotations are there, you're right. So annotations are there. I haven't used them much. I have been using without annotation things. So yeah. So this way you are able to execute any Python program from within the Pig script. Alright. So let's try to do that. Can you give me my charger point? Now let me SSH onto the server. Alright. Okay, so here we are. Let's log in onto the Cloud Labs, and so we go to sgiri. We have Hadoop fs -ls. So there is word.txt. You can see that. Now let's create mkdir. Yeah. So I've already created a file called lcal.py. You can see that. Lcal.py contains at output schema and then that column and then the function name. Essentially, we are saying here is this function, when called, will return a column called word with this data type. Okay. So I'll show you that. Now let's start Pig. Okay. Let's start pig. And here you can see that I'll have to say register my Python program. Register my Python program using Jython as library and give it a name called lcal. Okay. Now lcal can be called from within the Python program, from within the pig script. So first is load that word.txt. We are loading the word.txt. Okay, we loaded the word.txt into A, and now we are going to go through this list of words. So we are saying for each A, for each element of A, generate lcal.length $0, right? $0. And then when we do that, okay, so it has, now we can say describe LL. And also when you are loading this, it should give you a confirmation when you said register, right? Register. It should say, it should tell you that what it has registered. So yeah, it is saying that schema word.carry defined for function called length. Okay, describe LL. Now you can see that. Makes sense to you, right? So LL, the output contains a column called word with a char array. So basically, pig is using your program to figure out what will be the schema of the output data. All right, that's the reason why we have kept that schema. Now we can say dump LL, okay, and LL will give us the length of all the words using our Python. All right, so this way you can actually do a lot of cool stuff using your pig in combination with Python. So you may not generally need to go for things like what we did yesterday. Most of things can be easily done using pig itself. Whatever we did yesterday on Friday, finding tuples, can actually be done here easily. We can break down the whole text file into one word and another word. And once we have done that, we can basically order it, and that's it. So, sounds good to you?
So what you have done is fed in some data.
Yeah.
For each of this, what are the length of this word?
Correct. So yeah, so you can see this. So what I've done is I created a Python function to just compute line length. Okay, just computed the Python, wrote a Python function. It could be very complex. It could be very simple. Okay. So, and let's imagine that there is no length function in Python, pig, and that's why you have written this code. We could have actually written more meaningful code so that you get the, feel of why we did this. Okay. Or you realize that for n comma m, you have to generate that 001, 002. So you take the argument, you generate this, and that goes into the pig. So we wrote here a simple function, and that behaves as if that function was part of their library. So you can see here, Pitpal say lcal.length. Lcal.length is what we have just done. Make sense? Yeah.
So from your pig, you're calling Python.
Yes. From my pig, I'm calling my Python program. Okay. So as when we were discussing the basic premise of Python, Python is very interoperable. It can be called from within various programs and from various.
Using Jython.
Yeah, the reason is pig is written in Java. So under the hood, pig is nothing but Java piece of code. Now that Java piece of code need to make a call to your Python. That can be done using Jython. All right, sounds good. Now you can look at this a little bit more complex example. Okay, you can have a look at this more complex example. Say you have an output schema called, so either you can mention output schema. Also, you can also tell that the output schema function is going to be this name, which means when you're calling it from lcal dot, you will say lcal dot square schema rather than square. Okay. If you don't want the Python function as is in the pig, before exporting this Python into pig, you want some other function name. In those cases, you can mention the different annotation. These are called annotations in Python. Okay. So this brings us to a topic that there are annotations which have been introduced in Python. Now you can use these annotations to mark the piece of code, basically beautify the piece of code with various information. Okay. Sounds good to you? Sounds good. Jagdish? Bobby? Okay. Sir? All right. Now, imagine that you have one Python program which is calling other Python program, which is calling some other Python program. And we are importing this, we are registering your Python program into pig. What will happen? Then basically pig makes sure that everything is imported recursively. All the dependencies are loaded recursively. Just make sure those are available in the local folder or in the absolute path, wherever you're doing. All right. Okay, so Hive UDF in Python. So Hive is proper SQL kind of a platform where you write SQL and it basically churns data lying on HDFS. Hive essentially churns data lying on HDFS just like pig, but using SQL. So 99% of the time, I can assure you that you will be using Hive only. Most of the people who are working on big data, they are essentially using Hive only, meaning because it has simple SQL constructs, they don't have to do anything new. So in Hive itself, you will get stuck at a lot of points where you realize that there is no function for in Hive, say even breaking a single line into words. Okay, let's say we were talking about doing that using pig. So that part where we are breaking the word into tuples, A, B, B, C, C, D, like that, right? So that kind of work you can delegate to Python. That piece of code which you are not able to do either in Hive or in pig, you can delegate that to Python, and then you can call those functions here. Sounds good? Wherever that procedural kind of behavior is there, where you have to loop through elements, do this, do that, you can quickly code that piece of that piece of work in Python and load it here or load it in pig. Okay. So imagine this: you have this function. What it does is it cleans up lines, it splits line based on tab, and then do the transformation on each token. What is it doing? It's doing nothing but again joining all the full line by tab. Okay, it did nothing essentially. It took the standard input, cleaned it, and then joined it. All right. Here you might say that don't join token number 0, join token number 1, and so on. Okay. So this way, this kind of a program can be readily used in Hive. Okay. So what you can do is you can say, you can copy your Python program into HDFS. This time you have to copy it into HDFS. Okay. And once you have done that, you can basically do something like any function call using this and as this and that. Okay. Now, how should I say? Here. Yep. So we are saying run this program over all of your data in this table and get the result. So essentially, we called this program here. Okay. So select transform means that we are running it like a streaming, meaning passing our data through that command. Sounds good? No? Okay. You can give it a try. All right. So should we start in a Spark part? Spark. You are going?
I thought we'll cover it in the. We'll come back in an hour.
Okay.
Is all a part of R is it or part of Python?
No, this is Python. Yeah. We're extending it a little bit, covering more of big data because people wanted to attend my session because they expected that how big data and Python works together. And that's the reason I've extended it a little bit more. Because, I mean, Python, usual Python, you can learn anywhere. But these are the few important parts. How can you make it work together? How can you make streaming work together? How can you do this? How can you do that? Okay. And Python with something like Python with Spark is a really good combination to work on because it gives you instant feedback. It lets you do complex stuff using Python. And that's the way the world actually would move. MapReduce is great, but for doing most of stuff, you can do using Spark. Okay. That's how it is going to go. So any questions till this point? No questions? I'll just grab some water.
So school में भी इतना टाइम पहले लिखना है लेकिन इनमें पूरा लिखना है it is like अत्याचार नहीं आप वाला इंजन भी छुट्टी लो आराम विंडोज का बिल्कुल नहीं है क्या तो आपको छुट्टी कैंसिल कर लो मेरे को सबमिट आपको मिलेगा ना और एक दिन आराम करो क्योंकि जब पूरा वी आर कंफर्टेबल जनरली हाँ occasionally मेल चेक कर लो थोड़ा इन लोगों को गाइड कीबोर्ड वाटर व्यू है ओके ठीक है
All right. So yes, any questions at this point? No questions. So we were able to quickly run our Python program. We can even utilize most of our Python code into it. So in simple words, whenever you have to do the individual record journey, and you are not finding a function available in Pig or Hive, you basically use your Python code. Right?
You ran that stock program?
Yeah.
You ran?
Yes, actually. Okay. So yeah. So the program is in my Google Drive and big data classes and my live training and Python. So yeah, see.
Google Drive can be accessed as a normal drive.
You can mount it locally. It creates a folder locally, yeah, and it keeps on syncing it. So you can say Python. This is what we run. So it gave us 26. So if you want to see what is there, this is the one. You want to add anything, change anything. We did not run for you. Should I have a look at your screen?
Show me the code again.
The code is here. Sounds good?
Yeah.
It did not work for you?
Yeah.
So there is a built-in snapshot button in the top right.
Yeah.
You could use it.
So the example here, starred one. Here there is a Python folder, and then there is an example, and basically all the examples are in. The examples are in this folder. You can use this folder. In this folder, all the examples are there. All right. Sounds good to you?
Do we have access of this drive?
Yeah, everybody has. Is it not allowing? See, I'm opening in the incognito, the same URL. And there are these 20 items. You can download any of this. Okay, all the functions which we have coded so far, I have put down in this one. Just that the names, maybe I can change the names. Sounds good?
And where is the tax one?
Which one?
Okay, tax.
Okay. All right. So let's try to execute our Hive program. Before that, we can actually create Hive, and in this I can say my Hive udf.py, and this is my line std this.
Then madam network reach the second is to the last.
Okay, so we can see Python Hive udf.py. This is correct only, right? says invalid syntax. Why does it say invalid syntax? Do you spot an error? Can you spot an error in this? Oh, square brackets are wrong. You'll have to put one more square bracket. So ideally, it should just pick up first two string and yeah, it has only picked up only first two, and that's it. Okay. So let's say this is our program. This is our Hive program, and we want to execute this program over our text, say big.txt, and see how it works with those. Okay. So we can essentially use Hive's streaming capability and use this. So this folder is Hive, and we have hiveudf.py. So we can say add file and hiveudf.py. We will have to copy it to HDFS. So let me just copy it, Hadoop fs mkdir asgiri/hive. I'm making a directory there. I have to put -mkdir. So everybody is comfortable with this HDFS, right? These commands. So we can say now, can anyone help me with the command to copy this? Copy from local. And then, right? So now we have copied it to our folder, and Hadoop fs-ls, we can say asgiri/hive. So you can see this. Okay. All right. And what is the present working directory there? How do you? I want to find out my current working directory there.
I think you know this type Hadoop also.
No, not that. I want to find out my current working directory. What is the name of the full file? df get fact help ls make directory move from local.
Then help cmd, then it's help
Change group append file stat Hadoop fs stat. I think the folder name is user fs ls/user. Yeah, /user/student/asgiri/hive. So I think this is the flow. What? Otherwise, I'll have to check from the hue. Yeah, this is correct. Slash user slash this and Hive. Let's launch this. So parallelly, we can open Hadoop 888. That is our hue, and we can check. So ls asgiri. Oh, that's not there. So we can say add file, and then we can say this, and we can say hive udf.py. You have to mandate hdfs colon slash. Says that the illegal character in scheme at index say hdfs this cause hdfs colon colon does not exist. Can anybody help in this? Oh, it wants me to put the username also. Hadoop 1 dot nobigdata.com. Let me increase the size of this thing. That's what I'm seeing. So I have to delete 5 characters. 1, 2, 3. Hadoop1 dot nobigdata.com slash user slash student slash asgiri does not exist. This is crazy.
I think port number also.
No, you don't need to give that. Maybe.
SDFS.
Generally, this is the way it works. Never mind, we'll look into it later. Okay, never mind, we'll look into it later. Alright? It's all a matter of providing the file name, that's all. So add file in Hive. Alright, so we'll just have a look at it maybe later point of time. Okay, we just need to see how is the path we need to specify. Okay. Alright, so we'll look into it later. Basically, the only idea here is that we are going to pass the data from our from Hive side onto the Python code, and Python code is going to read it from standard input, just like our streaming example of Hadoop, and then transform whatever it is, and then give it back as tab separated. If you remember that, I mean, the normal communication is via tab separated fields. Okay.
Can you, one last thing, you remove Hadoop colon slash will use line. I think it works for me using normal slash.
Okay.
Remove Hadoop no big data from.
Okay. So you mean to say
slash user, till slash user, you just previous.
Remove everything till the single quote or till the HDFS.
Single quote is also not required using.
I think single quote is not required.
Sandeep, what is the password for student?
The same one. No. The older one. Capital C. I'll just take it off. All right. Okay, so no, it's not working. So I'll have a look at it. No worries. Right? I'll have a look at it. Yeah, this is the easiest way to do it. Okay. So basically, without specifying anything, it is picking up from the local. So even we did not have to copy it to HDFS, and so we can simply say. So table is not found, right? So table, we can put any table here. And let's say we are creating a table. We can create a simple table called, whatever table we create, we can say show tables and say word count, not word count, user data, zip profile, tweets BI, tweet sentiment, students. So we can say select star from students. So let's say this is our table, and in our query we can write students. Okay, so essentially I'm removing everything. Hive UDF. Okay, there was no single quote. Actually, we are unnecessarily putting the single quote. We did not need to actually provide the single quote, and that single quote was the problem actually. Okay, so essentially here what we are trying to do is these records of students will be transformed using this command, and here actually we should have said Hive UDF. This is wrong. It will give an error. Okay, this is going to give an error. This is going to give an error. So let me just run it again. All right, so let's just try it. Okay, so now it's going to run the map reduce. Since there is no reduce involved, there is no grouping happening. So reduce task is not working. It's just only the mapper part which is working right now. Cool. Okay, so the stage 1 map is happening. So this map has finished. Now you can see it has basically removed the second column and kept only third column, kept only first two columns. In there were three columns, right? Earlier there were three columns. Now there are only two columns left because that's what we have written in our code. Now the column header for some reason has not appeared, and so column header for age has not come. All right, and that's another thing. Oh, we are saying second field has to be integer. Okay. In our transform, we are saying second field has to be integer. Sounds good to you? So we are able to pass our tables data through our Python program to translate it into one form from another. Happy? No? Okay. All right. So yes. So the important part is that when you look at Hive code or Pig code and you realize that this is not good enough, this is something is not solving my problem, you can create your Python code and get it linked here and run it. Okay, and the Jython binding is also there in Hive, and that gives a little bit more sophistication to it. And I think you can add one Python program and then get everything in place. So also, if you have a complex data structure like say JSON or say any other method, let's say your JSON code is in a mix and match of XML and JSON. Okay, some field is in JSON, some field is in XML. So in all those cases, you can write your Python code to do the parsing for you and give the input results to the Hive. So if you remember, we talked about two things. One was called serializer and deserializer, called Serde. So in the same manner, you can write Serdes in Python so that we can say select star, create my table using this data using this formatter. You can write those for serializer, deserializer in Python. Okay. All right. So now should we start with Spark? So it's 12:28. When do you want to take a lunch break? Around 1?
I need to take it now. It will be less crowded. No. Otherwise, we'll finish it off Python and how long?
No, it will take long time. It will take easily 1.5 hours. Okay. It will take easily.
We'll not start ours today.
Will it start ours? Will start ours. Will start ours. Okay. But I don't want to miss this part. I do not want to miss this part. All right. So let me stop the recording. So sorry. So here you can think of this is my page 1. Okay. And this is another page 2. They are voting for page 3. Voting as in they are referencing page 3. Okay. And then page 3 is referring to page 4. Okay. Now in my home page, I always mention, please go to Apache Spark and visit these topics. These are very nice. So, and then that Apache Spark will mention somebody else's home page and so on. Now, the people who started Google figured out that this has a very important phenomena. Important in the sense that if page A is voting to page 3 automatically becomes more important. And hence, page 4 becomes even more important. You getting my point? So if you have page 5 and page 5 is also referring ahref. So if let's imagine that initially if this one has got a rank of we give them numbers, rank of 1, this one has got a rank of 2. Okay, so this one will get 1 plus 2 and plus 1 itself by default one. So this is got 4. Okay, this one will get, and this one is 1. By default its value was 1. Okay, now it will become 4 plus 1 plus 1, which is 6. Not 5. This is not 5. This is 1. Okay. So now you can see that this kind of a graph made this as page rank highest page rank. So when people are searching, and in the result, the result matched with the keyword which are found on page 4 and page 5. It will display page 4 above page 5. Okay, and page 3 above page 1, page 2, and page 3. So when Google displays the result, it displays based on this rank. This rank. All right, makes sense to you? So that's how the page rank and the Google search results. That's the reason why suddenly Google became such an important entity suddenly, just based on this single algorithm. Okay. While before Google, there were lots of search engines. We all know that, but they were not good because they did not compute the relevance of pages based on who is referring them. Okay. So, like if there is one particular paper which is referred in multiple books, that means that paper must be very good, very authentic. In the same, that was the same analogy they also used. So, to compute this page rank, to compute who is more important, you will, when you start doing it, you will realize that it's a very difficult thing to do. Reason being, reason being, there are chances that page 4 is referring to page 2. So there are cycles. Okay, there are cycles, and there are things like page 1 directly referring to page 4. Okay, so there would be lot of complex cycles, and to solve these kind of issues, like here, these, they all are referring to each other. And imagine on the size of web, the same thing is happening on the scale of web. And how do you solve that kind of situation? That is where these tools come into play. If you have to tomorrow build your own kind of a, say, imagine in the Twitter rank, people can follow each other. You can follow me, I can follow him, he can follow somebody else. So based on that also, people, same page rank algorithm applies there also, in the Twitter rank also. Although there is no, I mean, no good solution right now, but people are will have already done it. It's just I don't know much. So basically, to compute Twitter rank or to compute page rank, you need to process graphs, and this kind of graph processing cannot be done on a single machine. Specifically, none of the graph search algorithms are n log n. All of them are O n into n. Okay, meaning if you have n nodes, if you have n nodes and m edges, then your total time which is going to go there to find a path from one location to another, to find to find best weightage graph and all of those, that requires n into n. Okay, meaning O n square algorithm, which are very time consuming. As I explained in the morning, that the difference between n square and n, it quickly became 10 seconds and 100 hours. So that kind of difference start happening. So because n log n and n square is not equivalent, n log n is more or less linear. If you think about it, it's more or less linear. N square is just jumps, and n to the power m is another situation. Okay, that's another level of difficulty. So these graph algorithms work on that kind of a difficulty level. The say, how should I say? If there are five objects, in how many ways you can arrange them?
I see.
Arrange. If there are five bottles sitting here, in how many ways you can arrange them? So first position can be filled by five things. Second position can be filled by four ways. Third position, three ways. Right. So it becomes 5 factorial. 5 factorial. Now imagine the complexity, and This is the kind of processing you do generally in graph and even the machine learning, where your data in normal life, in normal enterprise life, because we do not venture into the domain of advanced analytics, we all the most complex processing we have is n log n. If you have n data points, it will take time proportional to n into logarithm of n, which is more or less linear. And what is n log n? When you create an index on the database table, it's n log n. Okay. Now, on one hand, you have this complex processing where the outcome is far more complex than sorting the data. On other hand, you have the problem of handling huge data, which to read a data set from the disk itself takes time, right? So let me ask again. So if you have 1 GB of data in the disk, how much time will it take to load it into memory? 1 GB data. Just load into memory. No. No, in just there is 1 GB of file and you have to copy from one machine to another or same machine. C colon to D colon. How much time do you think it will take? It's 5 minutes. No, 1 GB. One movie.
More than 1 minute.
One hard disk to another hard disk. It's correct. On really fast drives, it takes around 10 seconds. 10 seconds to read, not write. Write will take around 60 seconds. Okay. So effectively, imagine this. Let's just say it takes 10 seconds to read 1 GB data. Now the moment data goes to terabyte. The moment data goes to terabyte, 10 seconds multiplied by 1000 is 10,000 seconds. And which is?
No.
So let me just stop it. And so we have 10,000 divided by 60 divided by 60. This is hours, right? These many hours. So it takes around 3 hours, but it takes around 20 seconds to read the data. So it means around 6 hours, 6 to 7 hours. 6 to 7 hours just to read 1 TB of data, just to read, no writing. Okay. I mean, it sounds simple to say 1 TB because we have 1 TB. 1 TB represents to us like it's 3,000 rupees. We can buy things. But when it comes to actually processing the data, when people talk about we are handling petabyte of data, petabyte data reading from a single disk will take how many hours? Uh, Here it takes 7 hours, right? It will take 7,000 hours to read from a disk. Which means if you have 1,000 hard disks in parallel, then you will be able to read it in 7,000 as 7 minutes, 7 hours. Sorry. So on 1,000 hard disks, you'll be able to read the whole data in 7 hours. So that's an important criteria when people say, what does it mean by petabyte, terabyte? This is probably the most important thing to remember. And all of you, so there is this GitHub, and yeah, I will show you numbers: disk IO, memory IO time. Disk read, memory time, GitHub. Yeah, latency numbers every programmer should know. So here you will see this data as really useful. Okay, so you can see that reading 1 megabyte of data sequentially from normal disk is around 20 seconds. Okay, 20 milliseconds. So 1 gigabyte will become 20 seconds. Okay, so these numbers are very important. So fastest is amongst all of the things, fastest memory is L1 cache. Then branch mispredicted if else conditions. That is the second one at the processor level. Then L2 cache reference, and these are the other numbers. Okay. So this will help you understand that the memory is 80 times faster. RAM reading from RAM is around 80 times faster than your disk. And reading from SSD is 20 times faster than the normal disk. Okay. Now you can understand why SSD is so better than the normal one. Okay. So now let's move ahead. So when you have on one hand you have this discrete problem, data reading problem, and on other hand you have the complex problems to solve. Then definitely you require a better solution than n log n. Okay. And what's happening? All right. Yeah. Good. So if you want to install, you can download this binary. I've already found out the installation binary for myself. So you can basically go to Spark homepage and you have spark.apache.org. I think my internet has again suffered. I don't want to touch it. Let it run the way it's running. Okay. So here you can say download, and under download you will see you can choose whatever release you want. Okay. I am using the previous one. This one, I think, not this one. I think this is the one I'm using. Mhm. I'm using a completely different one. So let me log in. I'm using 2.4, 1.1. I'm using 1.1 Spark. This is the one, November 26th. Okay, so you can download the Apache Spark for yourself. Maybe the latest version is okay, and then you can see that for various versions they have a pre-built one. Okay, prefer the 2.4 or 2.6, and direct download, and there in here you will also see the alright. Yeah, I think that should be good enough. If you download this is the one, and or you can use the Maven artifact. Alright. Alright. So I have downloaded this version from here, and once I have downloaded that particular version, I basically extract it and then move that particular folder to user lib, And once that is done, I move to that folder and remove that version number, just create a symbolic link to existing one. And then once that is done, I launch my PySpark. Okay, because it's in user/lib/spark. Under that, there is a bin directory. So now the moment I say PySpark, it will start. Alright. So now if you notice, now since you have been fiddling around with Python command prompt, notice it's actually a Python command prompt. So PySpark is nothing but Python command prompt with additional object. And what is that additional object? It is SC, which is Spark Context Object. Other than that, it's nothing but Python console. Nothing. Okay. So they have added one more object. The way browser had JavaScript with additional two objects. One is called window, other is called document. Okay. And other than that, there is nothing. Other than that, it's pure JavaScript. Similarly, in Python console, we are giving one object extra. Other than that, it's exactly same. Now, whenever we talk to Spark, we will involve SC. Otherwise, we will continue the way we were doing with Python. So, which means anything you were able to do, you'll be able to do here using your Python command. So you can say 2 plus 3. So it's as simple as that. Now, this SC command is very important to us. All right. So we'll talk about a little bit about conceptual level in Spark. So, and then we'll get back to doing hands-on. All right. So, okay. So here we are. So I think what I can do is I can give you on Hadoop 2, Hadoop 3, Hadoop 4. I don't have this on Hadoop 3, Hadoop 4, but I can download it because you might want to do hands-on parallelly as we are explaining, right? So yeah, we'll try to do that. All right. So the most important part to understand in case of Spark is the resilience distributed data set. It's nothing but something in the memory, or you can imagine resilience dataset as a big array. It's a big array, few elements on one computer, few elements on another, few elements on some other. And that's how an array is represented in Spark. So the array data structure itself, they have converted into distributed. And you will be operating on this array such that rather than you do a for loop to iterate array, you use map reduce filter. Okay. So this RDD, this resilience distributed dataset, is the dataset, is a virtual representation of your data. After Spark loads the data into memory, you can do an operation on this. The other important part about resilience dataset is, although it sounds like a single memory thing, this is located on one machine. These are distributed. Now, in case one machine goes down, that same array is shifted to another machine without user knowing about it. Okay? Without user knowing about it, this particular data set gets moved to another machine. So the complexity of failures is handled by resilience dataset and is hidden by the user. Okay? So that is what is resilience dataset. This RDD is basically put on multiple machines and you're given a handle to it. You're given a handle to it, so you don't have to go to each machine. All you need to do is interact with RDD. Okay? RDD is just, you can create as many RDDs as you want. You can create such kind of data set, as many data sets you want, while handling anything of the big size. Now, there is something called driver application. Right now, since we are launching it from the command line, our command line is the driver application. Once you have written your whole script, you can give to PySpark and it will run in a single shot. Okay? In that way, so that will become our Spark driver application. So the program which we'll write in Python will become our driver application and will launch on the whole cluster parallelly. So that's how it works. Sounds good to you? All right. So now we have HDFS, and so right now this RDD can be loaded from anywhere. It can be loaded by the Spark application from its own memory. It will send it to RDD. Okay. So this RDD can be generated from anywhere, whether from local memory, from local file, network file, and HDFS, or it can be loaded from anywhere. All right. Here everything is clear to everyone. Rakesh? No? Sir? Principal?
Sorry.
You lost it? Okay. Sir? It's okay? Alright. So yeah. So basically here the idea is there is this symbolic memory. It's like an array. We have one data type, new data type called resilience dataset, which is nothing but an array distributed over hundreds of machines or multiple machines. It's distributed. So 0 to nth index is on one, n plus 1 to this and another. And we don't have to know about it. Developer doesn't have to know the intricate detail and handle it. Also, if there is some failure of a machine, the same array gets shifted to another machine without user having to worry about it. Okay. So we can create as many RDD as we want. The way we create another array, you can create as many as RDD as we want using that SC object. This Spark context object. I'll show you quickly how would I create an RDD. So let's say there is an array, and how do you create array in Python? Using 1, 3, 5, 8 and so on. So this is my array, correct? Now to generate an RDD out of this array, to convert this array into RDD, you can say sc dot parallelize array. Okay, so this has been distributed over to the system, and now this has been distributed, this array, and now we can operate upon RDD. So we can create as many RDDs as we want.
So we have PySpark
Command.
So PySpark requires a cluster.
But this one is running in standalone mode, but it knows that where is my Hadoop.
Oh, we can't do yarn.
It knows etc Hadoop is there in your folder. In etc Hadoop there is all this config file is there. So it has
Spark also.
Hmm?
When we install Hotmail, we get Spark also.
No. They don't ship it yet. They are in process of shipping it. Okay. But yeah. So you can install it separately. And installing is quite simple. All you need to do is install it and inform it where is your Hadoop folder. From that Hadoop folder, it will find out where are the data nodes, where the name node, and will run whenever you launch anything, it will launch on those nodes. Say, for example, I want to read my big data.txt. Okay, so I think this is the one which I wanted to discuss. So there is HDFS, there is RDD. RDD, the other benefits of RDD is RDD can be used across multiple programs. Like an array is only limited to one program, but RDD can be used by multiple programs. It's like public variable. We can make it persist and then it will be public variable and others can use it. RDD auto recovers from the failures, meaning if one node goes down, it automatically recovers. Next is can have any data types but has a special data type called, so generally this RDD is nothing but an array. So it can have anything in it. Just each element can be either object, or it can be like a tuple, or it can be another array. So it's up to you how do you define your RDD. Okay. It supports two type of operations. One is transformation and other action. We'll talk about these two. These are very important ones. And each element of RDD across cluster is run through MapReduce. So I'll show you this thing. So either either we can say things like this. Either we can say things like this, where we are saying sc.text file. Remember, sc is our entry point to the game, and it says okay. So what we are saying here is we are telling Spark Context to load our file from HDFS into lines. Now lines will become my RDD. Now lines will become my RDD. And using parallelize, you can load anything. Now this lines will become my RDD. So we can operate upon these RDD using two kind of method. One is called transformation, other is called action. These are two categories of methods. Okay, so it says that lines is this file, and mapped read RDD and text file native access method. So this is basically a RDD. That's what I wanted to show you. And to convert any variable, local variable is a very easy thing. Okay. Now next is, this is a transformation. Okay. What do we do in the transformation? This is Spark application transforms one RDD into another RDD. Without having to bring it to local folder, it can transform the RDD from one form to another. Okay, and how can we do that? Using functions like map, using functions like say filter. So we can transform one RDD into another RDD. The beauty about map and filter and those functions is that we don't have to bring data. We don't have to loop through each. We just say, tell each RDD, the machine who is holding this RDD, this section of RDD, we tell them, can you please run my transformation and generate a new set of RDD out of my existing RDD? Make sense?
How do you get handle of those RDBs? Because
It will return.
anyways, it becomes public, right?
Yeah. No, you see, I'll show you. So
The question was what about
here, if you see what we are saying, line length equals, line length is the new RDD. My line length equals to lines dot run my map method. Okay, that's how you get the new handle.
so line length is your
New handle
make
to
it
RDD.
publicly available because
No, we
again
haven't.
an RDD.
We haven't made it public. We'll say persist. Only then it'll become public. Okay. So okay. So now here is my lines. What do you want to do with these lines? Give me some. So each line, let's say we want to capitalize all of the lines. Okay, fine. Or we want to just capitalize each word, first letter of the word. All right. So how would you write that? Anyone?
Yeah,
Let's define a function. Let's define a function called capitalize.
I think it's already there.
No, that only capitalizes first letter of the line.
You are overriding that.
Yeah, we are writing. Okay. Let's call it my capitalize. Let's not get confused. Okay. My capitalize. Now what does it do? It takes
String.
first it will remove all the special characters. And how do we do that?
Strip. No, strip cannot do that. Maybe we could call another function Or we could use what do you say?
Let's just say, okay, let's just say for time being, let me just capitalize.
Regular expressions. Get rid of all.
Little join.
Hmm? Right, just a second.
No, split. Split and join. What is that? So splitting and
Okay.
Split first word will capital and again join.
Okay, so we have, yeah, re dot sub. Okay, re dot sub. And what was the first one was?
Capital caret.
Caret. Not of A to Z, A to Z, 0 to 9. We want to substitute this
blank.
with, let's say, nothing. Okay, and this is my line, let's say. Okay, line equals to, say, okay, and then I say this. Okay, and let me just put tab and space in this also. All right, make sense to you? All right, now let me.
Where did we put space?
No, it will not remove space. Else,
I put a space here.
except space and tab and A to Z.
Okay. So what we say is, we'll just capitalize each line. We'll say new line. Let's say new line equals this. Good. And we say for word in nl.split.
Only one word we want to capitalize. Every word.
Only one word. Only every word in this line we want to capitalize. Okay. So we can say
Again, use sub. No?
if word
We use lambda.
0. Right. We can do lambda. Good.
We could use sub also. If the starting is small A to Z, convert it to capital.
Right. That we can do. But again, regex are not great for translating.
We do map.
Yeah.
Lambda word colon.
I think capitalize we can call now.
Yeah, that's what
Yeah.
I'm saying. Capitalize.
You can say,
Yeah, you can do capitalize. It should work. For each word.
right?
Exactly.
Now we can say,
Not capital.
we can say here, map, okay? And we can say capitalize. Will it work? I don't think so. No, it'll not work.
So for each word, no, you have to.
You have to call that, yeah? We have to say, we can say word, word, okay?
Word dot capital.
And we need to create a string also. Okay, we call it out, create an array, out dot append. We are doing this. Okay, so help me out.
Earlier one will what is a command line.
Yeah, capitalize. Help me out here.
Plus, you have to append that again with a space.
Return, and now we have to do this dot join, and I can say out. Sounds good. That's it. Okay, we can say return. Although all of this can be done maybe using filter and map, but here, okay, so we have just created.
You capitalize over there.
Is it?
Yeah. Spelling.
It will give error now. Capitalize, right?
Yeah.
No, but here you'll be able to just test it quickly.
Word dot capital.
Yeah. So word dot to lower and then capitalize. This is what I want to do. Okay. Sounds good. Sounds all good. Now we want to do this with the full file. Okay. Now if you see RDD, right, the lines we talked about, not here. Okay.
FT dot
We will do something else.
FT
Import
dot
RE.
just parallel dot
So all we need to do is we have lines, right? And what do line contains? Let me just show you what does line contain. Lines, let me say lines dot take say 10. 100 will be little too many. Okay. So you can see that. Okay. Also, the one thing I forgot to tell you, if the line is representing as Unicode, a string is represented as Unicode, it prefix the line, the string with U. Sorry, UTF-8 is represented as U. Okay. So this essentially means it can accommodate any Arabic character, English character, every character. Okay. Now,
But we need not be bothered on the distribution.
yeah,
We handle it.
yes.
So,
Okay. So you can define your Unicode like this also. While defining a string before string starts, you can put U. Okay. Now this is what it contains. Let's run our lines through my capitalize function. Okay. So my capitalize function is this. We will say sc dot, and as we were talking about, there are different kind of transformations such as map, filter, flat map, and group by. So map is what we are going to use. What does map do again? Anybody, do you remember? Transform one into another. So same map definition is there in our Spark also. Okay. So the only difference in the syntax is we call it this way. We say sc.map. Okay. And we say lc equals, lc is new RDD which we are planning to create, which is lines capitalized. sc.map, sorry, lines.map, not sc.map, equals to lines.map, and we pass my capitalize function. Okay. Now if you see, we can say lc.take20. Alright. It will show you 20 characters. Sounds good? Sounds good. It capitalized our strings. It capitalized our strings.
like
Yeah. So what's happening is here, Spark application, which is our console right now, it's telling Spark or telling the RDD to do the transformation. This transformation will result in another RDD here. Okay. And those kind of things.
and you can change multiple transforms, right? Dot
Yes.
map dot
Yes.
another.
Yes. So that's what I'm just putting it in another variable, and we can do that. Okay. Sounds good. So we were able to do the capitalization of lines over multiple machines quickly, reading the data from our disk and do that. Now we can save this output to back to the HDFS, and that's it. So we can do a lot of magic using multitude of machines parallelly. All right. Sounds good. Now, similar to our Python function, Python map function, here there is a map filter function, and then after filter there is flat map. So filter function, what does filter function do? Filter function let only the records pass which
Function returns true.
fulfills the full criteria by executing the function. Correct? So out of this full RDD, if we want to select only few elements and create a new RDD, we will use filter function. Okay. Let's say we want to pick up only the lines which are starting with vowel. Okay.
Lines, it will start.
Lines will be starting with something, right?
No, but it will not, nothing will start.
Why? A man sitting under a tree.
Or statement.
Okay. So like this, we have this line, okay, and this line, and we can say, what was that dir function? Okay. Here is there. Do you see any starts with?
Yeah, it is a last.
Is title.
This one.
And
Sorry.
line dot starts.
Line dot starts with, but again this will not be a great idea. Okay, true. And basically what we need is a different thing. What we want to find out is the 0th character of this one in A E I O O U. Okay, we want to find that out. Okay,
And
it's not working.
I think it's a error, right?
It's an error. No, this is not right.
This
Correct. We can also say upper. All right. What? Why? Now this time it did not work.
no, this one return error.
Okay. So we can define a function. Okay. So let's say we are define starts with vowel. Okay. And here is one line which is given to this. And all we need to do is get the f0th element. Okay.
Put this if
We have to put an if here saying if length of line, that's what you're saying, right?
no, we can put this itself to
Return line of zero after in
What?
yeah,
Because I'm afraid that there would be yeah. Sounds good. So we are writing a function which says that it starts with did it work? It's taking forever. So we can say yeah. So now this function is working. Now we want to pick and choose only those lines out of our LC, that which are starting with the vowel. And all we can do is we can say that start with the vowel,
LC dot filter
start with vowel equals LC dot filter, and we can say starts with the vowel. Correct?
yeah.
So this way we are able to delegate our headache to RDD. So this is where the functional programming comes into play. That automatically our map function and filter function, they became distributed. They became distributed automatically. And now SWV,
Take 10.
we can say tech and 10.
No, no, 20.
So
Yeah.
ebook and the project important up to here. Then author, addition, I. So you can see that we were able to filter our data very quickly using this part. Hmm?
Yeah, man.
So
You
I
can
started.
Scala also, right?
So I started with this whole Apache Spark course in Java, and then I realized that in my class it was getting very difficult to give a demo. So it took me just to do this thing. It took me full 1 hour, and then I said, "Okay, I give up. I cannot do it anymore." And then I said, "Okay, let me try PySpark," and this one worked fine.
But Spark best used with Scala and Python.
Python is good. It's really good actually. Why would a person learn a foreign language? Yeah. Somebody asked me to learn Bhojpuri living in somewhere. It wouldn't make much of a sense to me, right? And
Learning language is always good.
learning language is good, but it doesn't mean that I will learn some language which is not required right now. If somebody asks me to learn a language, I will learn either the Kannada or learn French or learn something else. That would be better, right? And yeah. So next is that similarly here, if you learn a newer language like Python or maybe some other more useful language, then that will be a little bit more addition. But as a habit, once you get to learn one language, it's easy to pick up other language because you are able to quickly see what is new in this language. What is new in this language? Say, I started, for example, with our simple C++. The moment I looked at Java, I liked about it was that it has automatic memory management, and I could basically don't have to fiddle around with pointers. So it became very quick to learn. Then when we after Java, when I moved on to C Sharp for some time, then I realized that in C Sharp it was very quick to make the UI, and there were really nice syntax, get setters, getter setters, and all of those. There were a few new things. Then when I learned Perl, I realized that data churning can be so simple using regular expressions. That was something which I learned from Perl, and multi-threading I understood from Java. And now when I learned Python, I realized that the command prompt is actually far better solution for programming than the text file mode. So I mean every language has something to offer.
That Scala IDE, when we type there itself, it will show the output. So similar to
Correct.
what we do in the command shell, it does it in the editor.
Oh, okay.
So the moment when we type, it will give the output.
Okay. And also when I learned JavaScript, I realized that it's so easy to modify the language itself from the program. That is something which is just marvelous. So modifying the language from the program itself, like using reflection, you introspect the object, you introspect the code. In these dynamically typed language, you can modify the code itself. Same case with Lisp. So every language has a lot of things to offer, and but Given my priority, I would basically learn something which is, going to be more used. Maybe I'll prefer Ruby after this. Maybe I'll prefer Ruby after this.
Ruby favorite.
No, it's used most widely. All right, and good. So next is the flat map. Flat map is like our map from MapReduce. The only difference with the flat map is if you have to convert one element of an array to multiple elements, you use flat map. Like using filter, you could reduce the element. Using MapReduce, using flat map, you could convert one element into multiple elements. So now in RDD, we have this. RDD right now contains what? Our lines RDD. Lines RDD.
Okay.
The RDD called lines, LINES. What does it contain?
Lines with capital.
Lines with capital. That is LC. So now we want to convert this RDD into another RDD containing one word as element of the RDD. Okay. So how will I do that?
One word.
So I want to break down this into one word. One word. Basically, right now this RDD is an array of lines. I want to convert it into array of words. What will I do?
You could use map or transform.
No. Map will convert one element into another element, right?
Okay.
Now I want to convert one element into multiple elements.
Can you go back to the slide one? Yeah. Each input can be mapped to
Each input one or more elements. 0 or more elements. Okay. Make sense?
Is there any
No, I'm asking this one only. Okay. So basically I'll use a flat map. And how will I use flat map? Can you help me out? So I'll create my function called two words. Given a line, it will convert it into array of words. And all it does is return line dot split. Good. So good part about this is you can quickly test whether your function is working or not by saying two words and you say this is a line. Alright. So now whatever we did in the previous one, SWV, line is starting with vowel, we could say SWV dot flat map and then we pass our function called two words. Oh, sorry. We have to put it into some variable. We have just wasted it. Now this is flat map. Let's say we call it words as WV.
Will it have array of array or one array?
This will be an array, single array. This will, because if had it been array of arrays, then whatever our map was there, that could have been a good solution. If you use a map, an inside map, if we say here, instead of saying flat map, if I say simply map, then it will convert it into array of arrays. Alright? So this way, W as WV dot take 10. Okay, so you can see that it has converted our lines, this array of lines, into array of words. Okay, so this is the magic of doing things rapidly and getting it done. Okay, now next is, so we have been able to do it. Next is I want to convert it into key value pair. Now I want to convert this. So we basically broke down our array of lines into array of words by using flat map. And flat map is like our normal map. In our normal map, we can give one or more output, right? But in case of map, we could only give one output. Map can only transform if there are n elements in array, it can give n elements. But flat map can convert one array to a bigger array. Alright? Now, let's say what I want to do is each element I want to convert it into tuple. I want to convert each element into tuple such that tuple's first value is my word and second value is my 1, numeric 1. So if I have to do that, what will I have to do? Anyone? Quickly.
Yeah, dot get word.
So all I want to do is, there is this array, right? Full array, or array full of words. I want to convert it into array full of tuples. Each tuple is equivalent of
Dictionary or something.
this bracket comma 1, this bracket comma 1, this bracket comma 1. What will I do?
In the same map, we can do tuple one.
Correct. Correct. So we can give either in the same flat map or we can run another map. Okay. So we can say we can write a function called. So what did I do just now? We It's taking too much of time, or alright. So this is what we just did. Okay. Now next thing we want to do with the flat map is we want to convert it into good. So this is how we convert it into one word in array of words of RDD. Now I want to convert it into key value. Okay. So what will I do? Define to tuple, and if given a word, it should return what?
Tuple of word comma
Hmm?
one.
Word comma one.
Word comma 1. Good. So you can see, right? We can say, all right. So to tuple, and I say this, so it has converted into that. Now I'll run it. So we can say words tuple equals to WSWV dot map to tuple. Oh, I forgot. Yeah, done. So now words tuple.
So all these operations are happening on the cluster.
Yeah. So not this. Only map and reduce will be happening on the cluster. If you start writing for loop here, right, they'll not happen on cluster. They'll happen on your command line. If you start writing something like for I equals to blind blue, then they'll
That is
happen.
fine. All this map.
Yes, they will
I
happen.
don't see any debug statement.
Okay, so I'll tell you. So just like pig, the computing does not happen till the point you say take. Okay, the computing is not happening till you say take. Similar to pig, unless we said store into file, it did
But
not do
here
anything.
we got the result, right?
No, we did not get result. It's just a symbolic version to symbolic thing.
No, take 10 is giving the
Yes, take 10 executes everything. If you say take 10, then only you see these debug messages, right?
result.
Correct? That's what you're referring to. So now if I say words tuple dot take 10, okay, now you'll see the result. You see the debug statement happening. Now, so we have generated the for full. If we say take 100 or say take 1000, we will see 1000 words.
Here, job quickly finishes
Yes,
because it is in memory.
it's in memory. Yeah, and moreover, it's running sort of in a standalone right now. Okay. All right. Sounds good. Sounds good to you. So this is how it is converted. Now we can do group by on this. So there is another function called group by key. If you have element in the form of key value, then you can do group by. Okay, because you have a key, you have a value like a tuple, then you can do group by on this. So all you need to do is you say group by, and that's it. It will run parallelly on the cluster and group these words, and then to group by you have to provide sorry. So group by will return basically the grouped version. It will not reduce. Now there is another function called reduce by key that will group it first and then it will run your reduce function. Okay. Now reduce function is very simple here. Alright. So I think a better thing will be to we move a little and then we'll come back. So group by key will basically group key value into key and all its values together. The only difference is group by key expects our RDD to contain tuples. Okay, to contain tuples. Now next is that
So the array will not make any sense here inside a tuple.
inside a tuple, yeah, it will make sense. It will give an error. It wants it to be tuple.
No, the array inside a tuple is possible.
It's possible. If you put a value, if you put a value as anything, it will work. Just that for group by, I think the key needs to be string.
Okay,
Okay.
got it.
So in the tuple, you can have key and the value. Key could be anything. I think key has to be string, while value can be anything. Okay. So this is the way you can do that. There are furthermore RDD functions such as sample. If you want to just take few random sample, randomly you want to pick element, then you can use sample. You yourself can design such kind of system. If you design things like things like map or flat map, what they do is based on a coin toss, it will give the output. Then you can do the sampling.
But all these maps, filter, flat map, all these are coming from
Spark,
Spark, right?
Spark, yes.
That API is Java.
Hmm?
Yeah.
Yeah, that's the documentation I've written. I have got the documentation from Spark. That's the best list of function I could find. Alright, so here if you see, we can do sample, union, intersection, distinct, group by key, reduce by key, sort by key, and join. So there are these another transformation function, but these are not purely transformation. They also include reduce things, action things. Okay. Now the next part in case of Spark, there were one form of functions called transformation. Each transformation returned another RDD. It transformed one RDD into another RDD. That's what a transformation did. Okay, sounds good to you? So one transformation, one RDD was transformed into another RDD using these transformation functions. Okay, and just like a speller where you have input coming, output going. So basically speller is the transformer converting one RDD into another RDD. So that kind of thing. So now the other aspects of the game is action. Actions are something that make things happen. While transformer just transformed in RDD, kept it there, but did not give you anything until you said take. The take was an action. Take 10, take 20, take 100 was our action. Make sense? So basically, action is something which tells RDD to give the result back to Spark. The way there was sc.parallelize distributed the data, reverse of it is bringing it back to the node is done by action. Action causes RDD to get converted into local variable.
So all our functional logic goes into transformers. This infrastructure logic goes into action.
No, both go into both places. So not only this, I'll show you, you'll understand a little bit more. So reduce is the one which is a action. Basically, what does reduce do? Reduce like sum. Sum will do, if you run a sum, it will sum up all the variables of the array and bring it down locally. So that is sum. Make sense to you? So action basically converts an RDD into a local variable. Action make the action happen. Transformation is just a statement saying please do it transformation whenever you whenever an action is executed. Until an action happened, none of the transformation happened. Like for example, until we said take 10, nothing happened. So take 10 is the action which is making it happen. So take, collect, count, and reduce. These are few actions. There are some more called first element. Give me the first element of the RDD. Give me the sample of the RDD. Give me ordered RDD. And save the RDD into the disk. That is another action. So these are our action which make something happen. Okay, which make things happen. And so most of importantly here there is something called reduce. Okay, and there is something called reduce by key. Reduce by key is interesting because reduce by key is partly transformation and partly an action. Reduce by key, what does reduce by key do? That is important. Reduce by key reduces based on a key. Okay, and what does reduce do? Reduce basically executes your function. Your reduce does is takes an array, applies your function on two elements at a time, and converts the whole array into a single variable. That's what reduce do. Yes. Okay. So
It's like multiple reducers.
right.
Reduce by key could be multiple reducers.
Okay. So that way you can see that it is. So if we have a simple array like, I'll first try to demonstrate the reduce, and then we will say define sum. Define my sum x comma y and return x plus y, and we have a array. We call it array RDD equals to sc dot parallelize 1 comma 3 comma 5, like this. It's a big array. Right now, since we can't type too much, we are saying, let me make it a little more humanly. We say array RDD dot reduce, and we pass my sum. So it basically will take two values at a time. First it will take, my sum will get 3 and 4, and then these, and here also we can say print got x comma y. Okay, I hope it works. Let me try to run it locally first.
Plus str of x.
No, it wants it to be converted into it, because that's a tuple, right?
Instead of plus, we can give comma no there.
Just a second. Yeah.
Instead of plus and casting,
Hmm.
we can.
Yeah, we can go give comma also. Yeah, that's correct. Now, good. So we are good here. So yeah. So we'll see that what all does it get. We'll just copy paste it, and at the end of all of this, we say print. Okay. Since it's a local variable, the moment we say reduce, it will return a local variable. It will not return an RDD. It will return a local variable. Okay. So every action returns a local variable. So what did we do? Isn't this correct? What am I doing? Yeah. So you can see that the answer is 64, and you can see that got has been executed this way. So first 1 and 3, 3 and 1. Okay. You can see 3 and 1. Then 56 and 4, 56 and 4. And you see the order? The order is different from what we had expected. And after that, GOT must have been executed on 4 and 60. Correct? So this way, this gives you a clarity on what's going on inside it. Alright? Basically 2 values at a time it's picking up and doing the job. And then summing it up. Now again, the same discussion. So average is not a valid reduce function. Neither is your the other functions like median. Those are not a valid reduce function. So reduce, filter, map. So these are the functionalities which Apache Spark provides you, which you can utilize to build a complex logic.
End of the day, all predictive analytics require mean,
Most of them, yes.
standard deviation.
Standard deviation,
Or variance.
mean. So if you look at these functions, they are nothing but basic algebraic functions that operate on sorted data. Correct? So alright, so this is clear to everyone. So count in the same manner. If you have to write your own count, what you will have to do is first generate 1111 for all the values and then sum it all. Okay, so here one step ahead, the array, say array. What happens in case of, I think for next, yeah, this example will show you better. Can you see it? So can you see it from there? No. Now better. All right. All right. I think this is okay. So imagine that we had lines on all the nodes. Okay. We computed using our map function, we computed their line lengths. Now we want to sum up all these line lengths using reduce function sum. Okay, we want to use that. So let's imagine that there are 3 nodes which are existing parallelly. On first node, some part elements of array existed. On second node, some element of array existed. And third node, some of the elements existed. Now, line length happened parallelly on all the nodes. Okay, line length happened parallelly on all the nodes. So you can see that line lengths everywhere on 3 nodes. Okay. And when we call reduce, so using map function parallelly, things are happening on all the nodes parallelly. Storyboarding is happening. Now, on the driver node, okay, so here we computed line length. Now the next step is we want to find out, we want to do reduce, we want to sum up the line length. Okay, so what will happen on each node? On each node, first 2 values get summed up, then another 2, these 2 values get summed up. Now we got 24 from node 1. Node 2, again nothing to sum up. Node 3, only one summation happened. But again, when this data gets collected on the driver node from which everything was launched, the data from all the nodes get collected. Again, the reduce function happens on the local machine.
But this will give number of characters, right?
Number of?
We wanted to, what we wanted to do?
We want to sum up all the line lengths. Total number of characters essentially.
No, that is
Right? Makes sense to you? So this is how the reduce happens. So reduce not only runs only on the nodes, but it also runs locally after the data has been gathered from all the nodes. Make sense to you? All right. Next is once you have this, now take collect, count. All right. Now should we try to create our word count? Okay. So let me just close this. So where were we on word count? We were here. We had converted into tuple.
Okay. Then we'll group by tuple.
We will do a group by called reduce by key.
Reduce by.
Okay. So we say frequency equals to reduce, sorry, we say words tuple. Are you with me? So we are saying reduce by key. And if you remember, what did our words tuple has? Words comma one. First word comma one, second word comma one, and so on. Now, when we say this, when we say things like this, we'll have to pass a aggregation function. So it will group it and then run your reduce function. So we'll have to pass our function like summation. Okay, our function like summation.
X plus two argument.
Yes, because it will break down like a binary search, two element at a time, and then build up.
Written X plus. Oh, we already have.
I've already written that. We could use lambda functions also here.
Shall we try with lambda?
Yeah, we can try with lambda. All right, or you want to try with lambda? Let's write lambda.
Lambda colon xy
lambda
colon
lambda x comma y colon x plus y. Okay. Now frequency. Now should I say frequency is anyway local, right? Frequency is a local variable. No, it's an RDD, right? That's only in case of reduce. If you can see that it computed the frequency of our words. You can see maxillary happens twice, desperate is once, rambling once, and so on. The only difference here is we have capitalized our letters and we have cleaned up our array. So feet has come 47 times.
Dexter has one.
Yeah.
Some words only one it is showing.
Where is it?
Dexter hydrogen 2.
Go to implementation.
No,
We can search in that big.txt, you'll understand. So yeah, you can say tender, you can say, let's say tendre, right? And we can go to my I forgot my name, big.txt. I should find it somewhere, yeah. So here you can see grep minus I. What was the word?
No, you will not find it there. Small t only.
That's why I put I. So it's only once. Okay. No, this is twice. There is one more.
comma is there, no?
There is one more. In this line also, is it there somewhere? Yeah, attendre is there. Attendre. I think because of comma, is it giving some problem? Hmm?
We didn't remove special characters, right?
We didn't include comma. Comma.
No, when we initially split the word, we
I
removed
think
everything other than a out of memory.
Yeah, but we remove comma as
we remove comma as well.
well. That is the reason.
Interesting, interesting. And what else? Let's just try a couple of more words. Say pestering. I have got blah 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 pestering. Is it a single line, such a big line? Yeah. So that has got only once. Spectators is enunciation, workman's. Alright? What kind of words are these?
It could probably be capital.
Merchants all. I think
No, with capital M also it could have been.
well, yeah, this one has been converted into merchants all. You got it? This one has been converted into merchants all. What? Alright, so
Merchants, how much counts as legal? But here so many merchants
no, merchants all. Merchants all. I was trying to figure out where is it merchants all coming from. This is where it has come. Alright, so we need to be a little more cautious when we clean up the data, and yeah, and we need to maybe when we were replacing non-alphanumeric, right? What we could have done is we could have replaced it with a space. Then it could have been better. Alright, so this way you can do computation using of our basic MapReduce. Now comes the shared memory part. Alright, so we have got something called broadcast variables. Okay, this was something we were missing in our usual MapReduce. In usual MapReduce, the MapReduce leaves up to you whether you want your maps to contact other service. Your MapReduce functions can contact databases. They can contact any service in the world. Okay, the way any Java program can contact any service, they can contact RDBMS, they can contact anything. In the same way, in the same way, MapReduce can contact them. But MapReduce itself does not provide you a way of coordination with another maps. Here, Spark provides you that. Spark lets you coordinate. Spark lets one application declare something to others. Okay? Spark lets one map function talk to another. When we say filter, when we run map, your map function can talk to another map function which are parallelly running over there. Okay, so that is one thing. It's like multi-threading with shared variables. Okay, so using shared broadcast variables, the applications can keep on informing each other. Okay, so you can see here sc.broadcast will broadcast a variable to all the nodes. So before you, in your Spark application, before you execute a map function or anything, you will write broadcast variable and then use the broadcast variable everywhere. Okay. So broadcast variable make it possible to coordinate amongst others. Okay. Now let's say we want to coordinate our MapReduce process such that the moment any of my applications encounter the word called
Dexter.
Dexter,
Other maps can.
the other maps can stop itself. Okay, so let's say we want to modify our program accordingly. All right, so this is important part because this is something which we haven't done. I myself have not done much on this part, so let's try it out. Okay, so let's imagine that two tuple. Okay, two tuple is doing that. So I'll just put this example in the examples itself and put it Spark. Alright, so it'll be available to all of you as and when I'm typing. As and when I'm saving, it will be available to you right away. So now what we want to do is we want to let our maps functions coordinate with others. Okay, my map functions coordinate with others. Or how should I say? I'm just trying to see what can be done. What can be done. So there is something called sc.broadcast. Help sc.broadcast. Okay, this is a broadcast method of PySpark context instance. Okay, so in the program we can say broadcast equal sc.broadcast and I can say some value or we can say false. Okay, so this broadcast variable is available right now. Okay, now broadcast dot value will tell you whether it's false or true. Okay, bc dot value, and I think I can help and not help
So
dir.
this is like a global variable,
Yes,
like shared across map job.
yes. Okay, so all I can see is path things. Okay, so I can say bc dot value equals true. Okay, and when the user wants to access, user can say bc dot value and it will return the value. Okay, so it's the we created a broadcast variable, and anyone who has to communicate with each other will be through this variable. Okay, now let's say what we are doing is we are writing a new map. On which word should we write? Should we write on the main word, let's say lines only, or
Sandeep, I got question.
okay,
Because it is said broadcast, if I set value to one map job,
just give me a second. So define two tuple broadcast, and whatever word we are giving, we are returning word comma 1. Okay, so what we are trying to do here is, while converting a variable into a tuple, we are making it global. So I think this is not a good idea. I would do something else. This is not a great idea. While running flat maps, two words, okay? While running two words, we will do the yeah. Okay, so where are we? Everywhere I'm putting broadcast, and all right, just give me a second. Here we go. All right. So now what is it that we are trying to do? Look at this piece of code on the last few lines. Okay, only last 4 lines. So what we are trying to do right now is, while splitting the line itself, we will decide whether to give out any value or not. Okay, based on the broadcast variable. So You remember our the old function? Two words. We are putting BC with this, saying split the line. Now we will put a condition here. Okay, we'll put a condition here saying if BC dot value equal to true, yes, great. Return.
You need to broadcast like that.
Yes. No. If by default I'm set the value to be false.
No, so we have to convert DC equal to false first, true first.
Right. Now we'll do that also. So when we split it, okay, when we split it, let's say this is my words array. This is my words array. If we encounter what word do you want to encounter? So okay, so this line will so just a second, be with me. So where did we capitalize this? Okay, that already so words are capitalized already, right? So we'll say if words,
Equal to rather.
so we'll say what word you were looking for? DXTER
Equal to 20.
in words, then inform everybody to stop processing. SC dot sorry
DC dot
BC dot value equals to true. Okay, now all of them will stop processing, and who all of them? The function itself, right? So if value equals to true, return empty. All right.
If already map is doing other map is already set for the condition is doing.
What?
I have 10 maps running.
Yeah.
I encountered Dexter.
Yeah.
I broadcast the value.
Right.
So it is the responsibility of other map to check this value, right?
Yeah.
So they check it, but that time I didn't find. So they are
Till that point of time, all of them will keep on processing, and as soon as your word reaches them, so look at this. So this code is going to run parallelly on all machines. Now Dexter can also occur on any of the machines. Any machine which encounters Dexter will broadcast immediately to all the people that I have encountered Dexter. Do not proceed further. Okay? Don't proceed further. Instead of saying that, I'm saying skip all the things. Okay? And now all these people also will listen to the broadcast continuously. Okay? And if they encounter that somebody has broadcasted Dexter, they'll stop their work.
Where is the stop loss?
So here we are just saying return empty.
Correct. Yeah. Suppose this map job.
Yeah.
We all map job. We started at the same time.
Right.
I found the Dexter and I brought up to false. But before that, we check for the condition and he is posting.
Yeah, they will all keep on processing. So there will be a little bit of a delay between the two. So you encounter Dexter, but you are not able to inform him, right?
Yeah.
Till the point you inform him, he'll keep on processing the data.
But once I inform,
then
he will not check it again, right?
No, they'll keep on checking it again. That's the thing. Okay. That's the thing. Okay? Sounds good to you? No? So Mithil, is this clear to you?
For the next batch of lines.
So this is a little tricky method here. So we are making you remember that puzzle people used to ask about robots? Anybody remember that puzzle? That two robots are dropped on a railway line. Okay, there's a big railway line surrounding the globe, and two robots are dropped on this line. Two robots are dropped on this line. Now they don't know which way they are facing. Now they have to meet with each other. What will they do?
Any direction they meet, right? It is
You're going opposite trend?
No, throughout globe wrong. Circular.
No.
The globe, it's a circular, right?
Circular track, right?
Yeah. So what if they are going parallel?
If they go in the same direction, they will not meet.
Yeah.
So
There are
they
four
have to
possibilities.
broadcast a direction variable.
There are four possibilities. Both are moving opposite to each other, or both are moving parallel to each other. If both are moving parallel to each other, they will keep circling, and the same program is going to be put on both the robots. Exactly the way we are putting the same program on all the data nodes. The both the robots have to be put the same program. Now they will move parallelly. Okay, either to the left, to the right, or they could bump into each other, or they could move away and bump into each other after some time. But how would you ensure that they meet?
Direction will broad.
Do you, yeah. So we are lucky to have that broadcast here. If there is no broadcast, it's not possible. Okay, good. So similarly, here also, so this code, this piece of code will be run parallelly on all nodes to convert each section of the array into words. Right? Yeah. We are breaking each line into words, and this is happening parallelly. Now, we came up with this idea that the moment we encounter a special word, or we should stop giving out the output, and that's where we use the broadcast variable. So we create an instance of broadcast variable. So we say bc.value equals to true. So that the moment he sees that bc value is true instead of false, default value is false. So it will start giving empty results. And in case it's not true, we'll go ahead and split the line, and then if Dexter is encountered into words, then BC equals to true. Otherwise, it will return the words. Good. No. Yeah. Clear. See that? I hope it gets copied. It says there is some error here. Unexpected indent. Where? Why? Why is it Yeah, I forgot the column. Okay, so alright, let me just run it now.
What are the some real applications and use cases? Like text mining or bot
Any statistical analysis, any statistical analysis, where you have a bigger data to compute, even including movie, if you have movie data, or even you have videos, you want to process them, all of that can be done. But these applications are not great to serve in a web application scenario. These are not web. Yes, more of like a analysis in the
So
background.
finally, generally the output will be some before
Some data, yes, that's correct. The other use case of Spark is Spark streaming, where we run, we basically use RDD like a channel, like a memory channel from which everybody is reading continuously. So now let's have a look at it. What happens in case of Let me say collect all, or what should I do? Should I do collect all? Collect. Let's do collect. Collect will gather all the data from all the machines back to the local machine. Will it stop ever? I think I should have put capital D right here.
Then otherwise it will break all the big text into what and
Let me just pick up the first word from here, okay? Let me just pick up the first word from this.
Immediately it will come out.
Here. So let me just stop at information, okay? Let's
I
just
think Dexter was also good. It was only in first result, but D was
D was small, right? Yeah. Now again, we'll say this dot collect and wait for some time. Oh, it did not stop. I think by the time one node reached there, others had already processed it. Yeah, that's the problem, right? So because in the parallel computing, this is something which is expected. Okay. Because broadcast will take some time to finish. See, even no matter how, the broadcast when it happens, there'll be a delay. By that time people have already started working. Okay. Although they have tried to be really, really fast, still. But here you can see that the total length is small, right? Or what we'll do is we'll do count, okay? We'll do count.
You are correcting one word, Dexter out of.
No, what we were saying, collecting means gather all the data. What we were saying is that while converting one line into, breaking the line into words, while doing that, please follow this, meaning as soon as you encounter a word called information, stop. Just drop everything. Okay. So also let me also check. How should I check?
Dexter will be totally active on that.
Let me just check few things. Okay. Let's say we have this array. We have this array. Array equals this, and when we say suddenly, suddenly in this, will this return true? Yeah, it's true. Okay, so this is correct actually. Suddenly or doubts. The logic is correct. It's just that there is a delay, and that's it. Okay. Now let's try to put the first letter, the. Okay, and then see what happens.
but you were written, you don't have multiple
No, but still they are running as multiple tasks parallelly. Still it's running as multiple tasks parallelly. Now this time it has only 11. Do you see that? And this time it is only 11, and you can see here. All right, makes sense to you? Now you can see here All right. So cool. So our logic actually worked, Mitesh. Finally, so you can see that the is not coming in the output. Okay, and I stop quickly the moment the is encountered. Okay, and the has encountered on multiple nodes probably, and therefore all those nodes have stopped parallel. So this way you can basically use a strong coordination between these guys. Okay. So now you can see sir, that we wanted to stop at the by converting lines into words. We wanted to stop at the keyword for the. So it has stopped at keyword for the and did not proceed further. Okay. All right. So is it clear to you how we did the coordination? Okay. This is how we do the coordination amongst various messages. Okay.
Do they have anything in the traditional map reviews?
No.
Rely on word programming.
Yes. You might use Zookeeper for that. You might use a database. You might use some other service. So yeah, because the way I'll little bit explain about broadcast. The way broadcast is designed is this. So there is this variable centrally, and the moment and each machine is having a copy of this variable. Now this variable is basically a pointer, and this guy the launcher has a reference of every node, and so the Spark provides this bridge where we can fiddle with this global variable. Now the moment we say we have changed this variable, so first thing it does is it quickly broadcasts everybody the variable has changed. It does not tell that what is the change. It just tells them that there is some change. So stop processing. Wherever there is a conditional check, they'll stop processing on broadcast variable, and then it tells them the real value. So wherever the if condition is there, they'll stop. They'll stop, and then because that when we say dot value, it's basically calling a function internally, and inside it there is a wait. So whenever somebody is trying to get the value from broadcast variable, it will wait if there is information from the center. So they have tried to make it really fast, the broadcast variable itself, and it does work sometimes to a very large extent. Okay. So in our case, it did work. So was that example clear, Jagdish?
Yeah.
All right. Let's take a break. Finally, somehow this time internet is working, although very slow, but it's working. I'm not even touching. I'm not even touching that thing. Good job.
कंपनी का भी अक्सर समझता नहीं है पहले तो इंफ्रास्ट्रक्चर आर्किटेक्चर में आता है जीपीएस में आता है तो कोडिंग बनता है वही आईबीएम में आता है नहीं तो एक बार समझा कि दूसरा कोई डिसीजन में क्या मतलब वो ऐसे में जरूरत है वहाँ पर क्या समझ गया प्लेन पढ़ना प्लेन उड़ाना सिखाने के लिए ऐसा लग रहा है इसका और इसके बीच में क्या कभी प्लेन उड़ाने वाला ना मेरे तो कोई प्लेन उड़ाने देने वाला
मार्केट को वाइग्रा खिलाएंगे तो उठेगा मार्केट मैं क्लास में भी कभी बचपन में स्कूल में भी कभी 2 घंटा 25 मिनट बिना ब्रेक के बैठा था नहीं बैठा था यार सुसु लगाए उधर वो लोग पिंग कर रहा था मीटिंग ज्वाइन कर रहा है क्या फाइनली बॉबी बोल रहे we started our.
सबसे मजेदार क्वेश्चन तो देवाजी ने पूछा 12 बजे तो ये तो बाटा बाटा एक तो लेट आया
ये राकेश नेक्स्ट टाइम से यार तुम पुणे से क्लास ले लो यार
आने वाला नहीं हो, सीरियसली नहीं आने वाला।
तुम्हारे वजह से हम लोगों को 10 दिन एक ही क्लास में बैठना पड़ता है। मेरी वजह
All right, so I think it has got connected. How come it's not connected?
Yeah, it's saying copy.
Hi. Hi. All right.
All right. So I think it's not really audible.
Never mind. Should we? Do you see my Bluetooth? Yeah. Finally. Yeah, finally it's working. All right. So we were talking about broadcast variable. There are another kind of variables called they are called accumulators. They are called accumulators, and these accumulators are used. These accumulators are used to gather unidirectional data. Okay. So as we noticed that broadcast variable has a little bit of a latency. They have a little bit of a latency in the sense that as you encounter a broadcast variable and you announce it, it takes some time to reach to the other nodes, right? Till that time, those nodes will start processing and might go a little ahead. But if you want your operations to be a little bit more faster and only unidirectional, then you like to go for something called accumulators. Accumulators are one-way variables. They are one-way variables, and so you can see that here we have accumulator, we have declared it, and this variable, all the nodes can only push data to it. They cannot read the data from it. So when nodes have to push data to it, then they use accumulators. These are great for reporting the progress. How is our map going on each node? They are good for counting the records. They are good for stream processing, where we are trying to figure out how many nodes have received the data, what's going on. So in all those cases, accumulators are a great way of doing things. All right. Now, accumulators are only added to through associative operation, because things are going to come in parallel. There is no guarantee that which comes first and which comes second from various nodes. So when you talk about accumulators, you should be pushing the data where the order does not matter. Order of things do not matter. Only in those cases, accumulators make sense. All right. So we can try it out. We can try it out. How does it work? So let's see if I'm able to make it work. So I can say dirsc and see what all functions are available. So you can see there are many functions which are available to us, starting with accumulator itself. Okay. So you can say accumulator and specify initial value. Okay. And inside our this function, say here, let me just define another function called define two words, and I call it accumulator. And when it's splitting the words, okay, it's basically writing to the accumulator. So I'm just taking it to the end. All right. Here, the way we are going to do is like this. All right. And then we'll say collect, or let's say we'll call count, not collect. All right. So we are writing another function now to convert our lines into words by using accumulator. So first we define accumulator. Accumulator is something like this. Accumulator is something like this. And okay. Now you can see there is on accumulator, there are many variables available to you. Okay. One is add, other is value. Okay. So acc dot add, I can say 10, and so acc will have that value, and then we have, what do we have? Add, acc dot add, what does it do? I don't know. Okay. Accumulator. All right. So that way we can basically add value to it. We can say acc dot add 10 again, and we can see the value in acc. Acc dot value. Okay, it's getting increasing every time. All right. Now all of these nodes can keep on saying acc dot add, and we can say what we can say, add, say line words dot count, number of words we are pushing to this. Okay, this way we'll basically count total number of words that have been processed so far. All right. This way we can count all of the words processed so far. and okay, and we say okay, and we could have actually said something else. We could have defined here the print acc dot value, okay, and see how it goes. Did it work? Okay, and now let me just work it again. Now let me see what happens. Now it's running, and what does it say? Value cannot be accessed inside the task. As I was telling you that you can only access it outside. It's a read-only variable, and therefore it's not allowing us to read from here. So we can say, and while these things are running, you can actually continue your other operations. And what does it say? Value cannot be, I'm not accessing it anywhere. This is correct only, right? What is it doing? Accumulator in do you see any problems? So that's what I'm doing, right? Do you see any problem with this? All right, we'll see to that later maybe. Let me see what is the value of acc dot value. Still 0. So do you see any problem with this? Anyone? So all I'm doing is a line dot split and then count the number of words, push it to the accumulator using acc dot add, and that's all. Okay.
Maybe try add one just for the time being.
Here, let's say 1 like this.
We'll keep on adding one.
No, it's actually still happening. No, it's not letting us do. I'll just have a look at it. Why? None type object is not iterable.
We'll check for line tiny field.
Oh, I'm not returning anything actually. I'm supposed to return something. I'm supposed to return something, and that's the problem. All right. All right. So you can see that total number of lines counted are there. And ac dot value does not invoke acc dot value does not should be updated. Sorry, we have not yet seen what's going on. As you can see, both numbers are same. Here the dot count as well as our this one is same. Okay, sounds sensible to you? All right. So that was pretty much about Spark. Now this is basically the normal word count. So who can explain me the meaning of each line? Who can explain to me?
I think we are loading the file onto
Yeah. See that? So this is our typical word count example, where at the end of it, we are only printing 10 words and saving it to HDFS.
We are taking the entire file in line.
Yes, we took the entire file into lines.
Function is splitting the line by a space.
Okay.
We are taking line into words.
Right.
Each line is being converted into an array of words. And we are flat mapping it, so it returns word comma one word comma one.
Not yet. Here we wrote a function, but we executed here.
Yeah.
Should I put a line number? Should I put line numbers here? That'll make your life easier. Okay. Now I think it can better work. Line number 1, we are saying lines equals to sc.text file, and then we are providing the full URL of the text file, and that means it's just a pointer to that file. Perfect. So lines is an array, kind of an array of lines. Okay. Then next line number 2.
Defining a function which converts lines into words.
Okay.
Then we are actually calling that function and putting it into a word array.
Then yeah. So why did we use flat map, not map?
One to many, right?
Yeah.
Because more
correct. Then
we are okay. 2 KB.
for each
So
word
for
we are
each word,
keeping
we are just putting how many words one.
right? We are converting
Function key value.
yes, tuple of word comma 1.
Saving it into word saving.
Correct. Now in the next line
we are again defining a function which returns the addition of those, summation of those.
right.
Okay. And in this, when we say reduce by key, what it does is it runs reduces on each key that we have found in a tuple.
Right.
It adds those.
Correct.
1 plus 1 plus 1 plus 1.
For each tuple that will happen. Correct. It's like group by and then calling the aggregator.
Take and will give you the first word followed by how many occurrences were there.
Correct.
Then you are saving it.
Good. All right. That sounds good. If we have to compute average, who can do the average?
Average can be reduced.
average we will have to write.
So let's say we want to compute average length of words, or how should I say?
Average line length in that file. Correct. Average line length.
Can we compute it?
No.
For each line length we calculate, and again each count.
Reduce is not working average.
No, we don't calculate average at a time.
we'll calculate count and then we'll calculate.
So, okay, length of the word divided by occurrence of the word. This is what we want to compute for each word.
Yeah, that we can do.
Yeah. How would you do that?
Reduce by
Reduce length of the word divided by number of occurrences of that word. Length of the word divided by the frequency. How would you compute that? No, let's say I want to figure out that how good the compression is going to be for this file. For compression, the word's length should be repeated enough. It should be big enough word and should be repeated enough. Okay, so that's what I'm trying to compute. So the number of words in a word, number of characters in a word divided by total number of occurrences of that word is what I'm trying to figure out. The compaction factor. So how will you do that? So this is clear to everybody, Prithpal sir? It's clear?
Yeah.
So first we loaded the data as an array, RDD. Then we did a flat map, converted each line into array of words, which means that it becomes a array of words, multiple output. Once we have array of words, we convert each word into tuple of word comma one. Now we got array of tuples, big array of tuples. After that, we did a reduce by key. Tuple means two value, key value. Now we do a reduce, means group by on the key, and then for value we use this function for aggregation. And once we do that, we get the frequency of word. Now question is, do you have any other problem for me? We can think about some solution, because this is far more important than anything else. Okay, it's far more important than anything else. Yeah. Do you have anything in mind? You have a question? Because the general trend is that everybody thinks that the only problem that can be solved with MapReduce is the word count problem. Okay, there is nothing. You can't solve anything else with the word count. So take your real problem. What is it that you are trying to take?
A real life example is the requirement for getting to start correlating certain keywords.
Correlating certain keyword with?
Yeah. So those are based on certain criticality. Maybe I create a dictionary is what I can just think of. But how do you? So first filter is definitely going to be a word count. I would want to know, say, out of the following words, storage is the most important word which is being used in the entire set of keywords which I have.
Okay. So you did a frequency analysis of the words. Okay.
After that, I want to correlate that maybe storage with the SAM. Is that a frequency being used? Correlation.
Yeah, correlation as in what are the words that are coming up together, right? So again,
not together.
Then
these are from the same technology. I would want to group them by technology, or it will require that kind of.
You want to group them by technology or something like that, right? Or you want to just.
Or maybe related to a specific domain.
So what you are trying to say is, let's say there are keywords. And how should I say?
I think of this an array with a key actually. Like for storage, you could build a dictionary with say storage and storage area network.
Come again?
Build a dictionary for each technology.
I will try to build a dictionary for multiple values. An array of values, basically. One key having multiple values. Like, domain, it could be, network, storage, blah, blah, blah. Then for storage, it could be again a list of values. And then I would basically serve.
Thesaurus, you mean to say? You want to build a thesaurus?
Yes. I'll build a dictionary of my own, basically.
Yeah.
Which could solve this.
How would you build this dictionary?
No, that is the manual effort.
Some expertise, okay. No, why don't? No, there'll be a lot of already available thesaurus. Why? No, there are. No. You go to open source. Trust me, I can tell you that there are lots of So how do people figure out this? Okay, how do people figure out this? So in a sentence, if there are two simple sentences looking exactly like same in the same context, they, I mean, Google has done a marvelous job in that. Okay, even the people have figured out the natural language processors. They have figured out a big thesaurus already. Like when I do a sentiment analysis, we do a good example where we have this. Okay, so there what we do is we go through a dictionary, we compare the sentiment of each word against the dictionary, and then we do analysis of the text. So I think you did not finish this project. Okay, and that's why your certificate is still not released. So yeah, so here there are many common new methods also available for sentiment analysis using this. I told you, right?
Better not do this. Hear all that now. It's over now.
It just tells me that you did not hear even about the assignment.
No, assignment when it comes, brain goes out of mind.
Brain goes out of mind.
Please open. Okay, it's actually stepwise details about how to do the sentiment analysis of Iron Man movie. You can put some other movie and then try to figure this out. Okay.
Is it based on?
So now you can see the dictionary here. Dictionary is probably the most crucial thing out of it. Pritpalji? So here we have a dictionary. So in this dictionary, you can see that abhor is a negative word. You can see that? Okay. And evidence is a positive word. So absolute is neutral, and absence is negative, and above average is positive. Above is positive. You can see, and there is polarity and in sentiments. There are two things. You should understand those two things, and that's what here we have.
How do you come up with, so dictionary gives you a positive and negative.
Yeah.
The problem is how to tackle a combination of those keywords in entirety so that
Come again. I need to understand.
in a sentence, I'm saying not a good idea.
Not a good idea. Yeah. So that's why this whole technology, right, is in a situation where it's improving every day. So one way is to do the even odd summation. Okay, you give the negative word as odd number 1, positive word as 2, and neutral as 0. You sum up.
Yeah, so not bad becomes a good.
Yes. Yeah, that's what I'm saying. Not bad becomes a good.
Yeah.
Okay. So, the sentiment analysis which we did not do. So your problem statement, I need to understand that. Maybe I can on prompt to suggest something.
No, we are already doing this. We are putting it.
Yeah. What was your problem? If I can understand it, maybe I can suggest what is the end result. What we're looking at.
What you want to come out is kind of build up a systemic issue pattern based on certain keywords.
System issue pattern.
Not systemic issues, like within a specific domain. What are the keywords being generated, and then what are the remedial measures? More of a technology related, but I would use some of this kind of algorithms or something of that kind to do that keyword map. See, the first part is that we'll have to find out the keywords and then do some correlation. Now, the correlation aspect, I don't know. But then from this correlation, I need to come up with certain patterns. What are the pattern patterns within that word system. Definitely not the following words.
So this is regarding when people are adding the issues, updating the issues, when they are facing the technical issues on the. So you have some issue tracking system.
Yeah, something similar to that.
Where you have people ask for resolution.
In one statement, I want to create some proper kind of patterns from those suppose tracking systems.
Basically,
So what will, I mean, there are many patterns possible. So let's just focus on, let's say, one aspect. Okay. So one is that when user is typing an issue, say I'm facing some issue. So when I'm typing some issue, you want to give them better results. Okay. Even before the user logs a issue, you suggest that did you mean to do any of these things? Okay. Did you mean to do any of these things? Okay.
So for example, in talking about storage, if I'm typing storage, you want to know whether the stand-related issue, related issue, what is it?
Right. So one is that there is something called a keyword analysis technologies. Yeah, what we do is the way it is done is we remove the common terminologies. Like given a full article, there are really good algorithms. Given a full article, it will give you 10 keywords that represent the article.
So this is there in the Maplib?
Not Maplib. There are open source libraries for this. We call them something like context. I'll tell you that part. Yeah. So what you give is you take the full page, full text, give it to the algorithm. It removes like junk from it, the, and, of, the, and will give you 10 keywords which represent this article.
That is a good starting point for me.
Okay.
The end point.
Yeah. So similarly, when the user is typing, so pick up the sentence, figure out what are the prominent keyword in this, and then map to those keywords in the issues.
So some part of Watson is already being used. Some part of Watson is already being used.
Okay. So you have question here is, let's say let's just do it, because the main problem which I found with almost every engineer, be it R or be it any other technology, the problem was with figuring out the problem statement. Okay. And the problem statement right now here is what we want to do is, let's say for each word in the text, we want to compute this length of the word divided by frequency of the word. How would you do that? What with the practical application? This is a compaction factor. Okay, compaction factor in the sense that if the length is bigger and it's less repetitive, that means it is no point in compacting. Or you actually multiply the frequency of word multiplied by frequency. Or you can say a better one would be frequency multiply. So length of word multiplied by the frequency of the word is the compaction factor. And let's do a normalization of this divided by max length. Okay, divided by max value. Whatever comes at the top, maximum of that divided by the max. Normalization is this, right? You basically take all the values, divide each value, divide by max.
Max is
Out of these values. So you first compute the length of word into frequency of the frequency of each word, and then divide it by max. Okay. Okay. So this is a common thing. Normalization is a common phenomena everywhere, and you use normalization that way because this value will always be between 0 to 1. It cannot be above 1. So it's actually pretty straightforward. So yeah, anybody? Jagdish, can you help me out?
Can you again say what is max here? The first
So okay, so let me ask you this way. So first you compute the frequency of words,
already done.
then you multiply it with the length of the word, then whatever value is coming now, you compute the max of this
Okay.
across all words.
Okay. Got it.
Then you divide it by the max. Okay. All right. Yes. So tell me.
But I don't know whether it is efficient or not.
Doesn't matter.
We
Doesn't
have
matter.
already found the frequency.
Yeah.
Now for each word, right? We will on WC, right? We will say the length of for each word, and we will put that.
Right.
Then what we will do is we will again have a reviews on all this, the new
Yes.
element that we have.
Yes.
And we'll find the max.
Yeah.
And then again we'll go back to.
Let's start writing quickly. No, I just keep speaking. I'll keep typing.
Okay.
When I was in my second year, so I found a senior who had a computer with who I was working. I had built half of the project myself. So this person was heavily paranoid. He never let me touch the computer, and that was the biggest lucky thing for me because I used to dictate code and he used to type it. So actually, it became really, really good for me. Afterwards, I realized that that gave me ability to analyze code better. He used to type it. I used to speak it, and my debugging skills, all of those things actually improved because of that. So yeah, tell me. So lines equals to load. Okay, let's assume that lines already exist. So you are saying lines to word you are going to use from here. So let's say we have words already. Okay, lines dot say flat map, and then we say lambda line, and here line dot split. Okay, so here we get the words. Good. So don't have to feel bad that you are starting to like Python. Okay. Yes.
Now for each word, right? We will append 1.
For each word, you will append 1. Okay.
I mean, comma 1. Tuple. We will make a tuple.
You will make a tuple like this.
Yes.
Okay. Let's say we have tuple now. Okay. Now
we will work on this word KB and find out the frequency.
Words KB, you find out the frequency. Okay.
So it will be written X plus 1.
Okay. You will be doing on this. You will run a reduce by key.
Yeah.
Reduce by key, and you say lambda x comma y and x plus y. So this will give you the frequency. Okay. Word frequency. No.
Other thing what we will also do is, it will also have word also, right?
Yeah.
Key will also be there, right?
Yeah.
So what we will do is, we will now we will run one more reduce function which returns the length of all the words. So it will be like words of len.
Okay.
And instead of lambda x plus y, we will say len of word.
Come again. So what do you want to do? You want to compute what?
No, we need to find out the length of each of the words.
Length of each word is there already. You want to multiply that with the frequency. We could directly multiply. Correct. So we can say multiply. Okay. And then we.
In the above word frequency only, that statement only we can multiply by length and take as a couple word comma word factor.
This will be okay, right? Which one? Here in lambda. Yeah.
There I'll return a couple word comma word factor. Word factor is the expression star word length.
So lambda does not give you the actual key here. Lambda does not give you the key. When you say reduce by key, na, you don't have the access to the key. You only have access to the value.
That is the problem.
No, entire that one will give frequency, right?
This one gave us the frequency.
That line. Word dot map dot.
No, we can't do that in single shot because that's happening on two values at a time. You cannot divide that time. Remember the average problem?
So even you can multiply your length here, right? It will not be true.
So okay, you are saying here. Oh yeah, actually he is right in a way. So here rather than putting 1, you could put length of the word. So if you sum it up, it will be
And divided by length of the word.
No need.
So if my word is, let's say.
So it will be that length will be added so many times, right?
So if the word length is 4, it will be 4 plus 4.
Yeah, that's what is to be done. We are saying length of the word into frequency.
Okay. So you are okay, fine.
Makes sense, right? Yeah. Because every time 2 words are going to get added, and this is what we get, right? So this will get us to this point. Now find the compute max. Okay, we say max equals word frequency. Yeah, we can do that. Compact factor.
You can again say reduce here.
Let's call it compaction factor. Okay, we call it compaction factor dot reduce, right? And we say lambda x comma y return. If okay, so we'll have to write a function. I cannot do it. Or you can say, I think min will work. Okay, lambda x comma y return min of x comma y. Okay, this will give us max of. We'll get the max. Now we got the max. Now we run the again. We run the
word CF by max.
Word CF by
max.
Yes. Now we can say word CF normalization. Okay, good. Dot map, and we can say lambda, and whatever is the value divided by max. Okay, so this way we can get the full file. All right. So let me just run it. Do you think it will run? Looks like.
If you have to giving the choice between Hive and Python to do the same thing, necessary choice would be Python.
I would prefer Python. Yeah. No, but Hive is different.
I would give it Python, Hive, then your.
Why Hive? Why? I mean, why are we comparing Hive and Python? Pig is good in terms of when you are writing order by select query, joining this, that. Typical data operations, right? Typical data operations. Then your pig is good. But when it comes to procedural, functional, kind of you have to loop over it, delete this, those kind of things become complex in data-oriented languages like SQL. It's become difficult to write a loop in those kind of technologies. There, what you do is you generally mix and match. So you write Python function, you call those Python functions in Pig. And generally the roles are sometimes divided. Analysts have to work on Pig or Hive, while developers will provide them functions, specific functions to do things. Okay.
But typically, practically, how your role doesn't exist, right?
Which one?
In any technology, there will be some role. But in actual work environment,
not every environment is same, but there are DB admins, right? In the world, there are people who write BI only, right? There are a lot of people who write BI, business analytics reporting. They will have to move to Pig.
Organizations are not yet matured to that kind of data. Falling about not just recruited anyone, like client and paid. Yes, it all depends on how the organization is structured. If it's a startup, they want to develop something of this kind, they might hire a few people. IBM is already structured as per client. Why should we create a new one?
So good.
now in actual hours, what I'm seeing, that Python UDF and Pig script should be developed by one guy. Though it is a two goal.
Yeah, but other guys will maintain the data. Okay. See, if somebody is doing things frequently, like I'll give you an example. So at InMobi, right, we had a lot of data coming from the user. Now, till that time, Pig was not mature enough. Okay. So now there is a lot of data coming in all the time from web server. People from all across the world are playing games, doing this, doing that, and we have the record of that. Now, our product managers, our program managers, our senior management have to keep on seeing the reports every day, that how are we doing. Now, since this data was so huge that it is quite difficult to do it, because the data I'm talking about was around 300 terabytes. Okay, not daily one, but overall over a few months, it was like 200 terabyte, 300 terabyte over like few months. Now, every time somebody has to decide upon a strategy, they will have to query this data. Okay. Now they cannot keep coming back to the developer again and again to develop a report for them. For them, they will go for this guy who knows Pig, and he can quickly write query and get the results. And after some time, product managers themselves started writing those queries so that they don't have to come back to anybody. Okay. Because writing the query was pretty easy. All they wanted to do was tweak with what?
Nothing.
Well, all they had to do was tweak this, tweak that, and then they had to just order by, group by. They could figure this out. Okay. 90% of their work was done using that. We gave them a single query and they kept on tweaking it. So it says that tuple object is not callable.
Oh.
Yeah.
So it contains key and value, which is
What?
What CF?
Word CF will contain.
What map TV will depend?
Should be words, not words CF, right?
So see, we converted into key values. Okay. Key value, key and value. Then we did a reduce by key, and the result will be word CF.
Okay.
So word CF would look like word CF dot take 10. Okay. Now once that is done, we are doing reduce. Oh, you are right. So reduce by key we have to say, right? No.
No, key will still be there, right? Words here or no? There will be key there, right? In words here. Can you type? Can you print words here?
Okay, that's what I've done. I got it. So word CF is there.
Yeah, it will be there.
Now we have to count the max of all. Okay, that means we have to generate, no, first we have to generate another array that contains only the values. And then we have to do max on that. Right? We have to do, say we have to do map, okay? And map will get, we have key value, right? In word CF. Map will do lambda.
No, I mean, what I was saying here was,
Whatever value comes in, it has to give v0, right? And then once that is done, we can do max on that, okay?
no, we could have written lambda such that if max is greater than value, value is greater than max, max equals to value. We could have written that.
If
So I'll start with max equal to 1.
so, it's doing something. Looks like it's doing something.
What I was saying was reduce function something like if my value is greater than max, then max equals to value and return max.
But max has to be communicated all across, right? So then we have to use broadcast or something. Correct? So it's doing something. So I think it's correct. This syntax is correct. We converted the key value pair back to single value and then computed max over it. And that is our max value. And then we'll do the rest of the things.
It should be V of 1, right?
What?
V of 1.
V of 1. Oh, right. You are correct. You are correct. Now it has gone for a toss. No, not confused. It's basically doing a string-wise comparison. It was doing a string-wise comparison. So now you can see what is max. Yeah, it actually takes time. Yeah. So that's the max value we have. Okay. 2 lakh. Yeah.
What is the file? Are you sure this is right?
I think this is correct.
Can a word be repeated 2,15,000 times? Is it a space?
Yeah. It's a space. There is a space. Yeah. There is a space.
Can you print this?
Yeah, which is the word? That's how we
Can you print this?
How would we know?
No, can you print this? If it is max, can you print it? Print that word here.
You want to say word CF?
Yes.
Okay. Dot.
Here.
Dot reduce.
Okay.
And then lambda. Okay. Lambda x. If x. Okay. If x equals max, return.
You could use filter, right?
X1, return x0.
Okay.
No, return this x. Because again this will be compared again and again. So we should bubble up only single value. We cannot say x1. Yeah. What? No, it's just reduce. Reduce only, right?
But do we have max, right?
What does it say? No, we don't have to say x. We just have to say this. I'm very bad at lambda function. I hate this function, but Sometimes it's quite convenient. Okay. I'll just write my function over these. Define my find, and I say whatever, and here if x this return x. Okay. So no, my find x comma y. Or filter, right? Filter.
No, earlier problem.
So we have to do filter, right? Filter.
Lambda should be one line, right?
I think I have forgotten the basic thing. Basically, we have to just do a filter. So here I have to just say filter, and for each value we are saying x1 lambda x equals max. Correct? This is my that well. Okay. Again, this will be an RDD. Actually, see that there is a delay, and that's what is irritating. Okay. What happened? So I think it's a space. I think it's a space.
Looks to me like that. Yeah.
So val dot collect, right? So it's a da. You can see? So it's da. 3 into that many times it has occurred. Okay. So if we replace da with a single letter, okay, it will basically reduce these many characters by 2. Correct? Instead of 3, if we devise a small symbol like single letter, that will reduce. So the compaction factor, the most of the newspaper we are wasting is for da. If somebody has to ask me, which is that word, which is wasting most of, because frequency is maximum. So what we did was length multiplied by frequency. Okay. So it's this redundant word da, which is actually eating up maximum space in the text. Okay. So now you understand the significance of the compaction factor, right? So this is that thing. All right. It's not the space as opposed to the common phenomenon. So we were able to compute that, and now we can basically do a map and compute our lambda function here. Okay, and what we can do is we are doing map, right? And word CF contains this, so we'll say, okay, it will return. These are key values, okay, key comma value, or we can say here v0 and this. Okay, make sense to all of you?
Yeah.
All right, I hope I was able to do this. So now words CF norm is containing your, all right, these are the compaction factors. But how come it's 0? Yeah, actually we did not multiply it by 1.0. That is the reason. So if we had multiplied by 1.0, it could have been easier for us. So this is how you generally do an analytics over the data, and you basically do these kind of clever tricks over the data.
This is a nice way of doing it.
Which one?
Converting into a float.
This one, 1.0 multiplication? No. These are very small numbers. So if we try to represent it with a symbol, it wouldn't make much sense.
10 raised to minus.
Okay. So that's how you generally do this. And now we can actually sort this data as well by switching the value by applying a map function, switch the key value, then apply the sort to order the data. Okay. So, I mean, the overall idea here I was trying to portray is that we need to figure out how to get out of the normal loop. In the first section of Python, I tried to explain the normal way of working of Python. And now using here it's a little bit of a difference. Okay. And these things probably almost every computing, every distributed computing relies on functional programming. Every distributed parallel computing function and distributed relies on the map, filter, and these kind of functions. Okay. All right. So that, yeah. Huh? No, I think we can. It's 5:30. We'll just, okay. So let's start with installation of RStudio. Okay. RStudio. So we will work.
We have RStudio for everybody. We have installed on a server, and we have user accounts for everybody.
Okay. Okay. I have also installed on my Cloud Labs. Okay. Just that in on Putty, you will have to enable few things so that if the graphics comes in, because graphics cannot be plotted on the terminal. So my server will throw the graphics back on your desktop, and your desktop has to handle. So those are the things. If you want to, if you have RStudio, well and good. Can you show me? I'll make use of. I'm making you presenter. So I hope today's session is properly recorded. But this is a very good model. I'll write a blog about it. How can trainers utilize these techniques? Because this GoToMeeting and all these have become free now. Although we have the paid version, generally if you want to use it, they give an account for free for 1 month. Okay, so these instructors can utilize, right? Yeah. I think it should be here. Yeah, I can see that. Now run. Can you start RStudio? No, this is, I think, our server.
No, wait.
Yeah, this is the one. Correct. Oh, nice. This is so good. This is good. Very good.
So this, for example,
Write 2 + 2 here. And say empty cars.
empty box.
M for mango, T for turtle, CARS. Good. Type capital V. Just scroll down. I can't see it. So maybe Control L or something. Yeah. VIW. I small. Okay. VIEW. In bracket empty cars. In round brackets. M small, T small, cars small. Good. So this is good. So your machine is good. This is good for all. So everybody can use this. Awesome. So yeah.
See, here are the user ID. Here are the user ID. How do I get my?
And just
Can you zoom it a little bit?
Just a second.
You could create, or you could do one of the ideas. It's not public, right? It has to be public, man. So it's public, it's free and software, yeah. Public. Need one more. Peter is there, no? Peter is there. Will anybody else? He will get almost 50%. The idea is not utilized. So Sandeep, I need to run it.
Okay. All right. Then, yeah. So our studio is set up already. So we can continue on Wednesday like this. But today's session has been good. That at least we have been able to think through. Okay. So it's a good. Yeah, it's good to have that because unless you solve the problems, because in IT industry, if you keep on solving problems, only then you stay awake, stay alive. Otherwise, it's yeah. If there is no problem, create one. All right. So yeah, I'll just try a couple of things and then we can. So I need to validate whether everything is working.
Take a random user.
Yeah. Can you just do this? Can you just do whatever you are seeing on the screen? C equals, so create a vector of -100 to 100. And
1 second. I'm locking. I have taken a different user.
what?
This logging is a different user just to see everybody.
Yeah, but I want to see whether plots are happening or not.
-100 to 100.
So it will basically generate all the numbers from this range. Y will be square root of each one, and then you can plot a nice graph.
-100 to 100. What is the other plot? Plot XY, yeah, plot XY.
This is plot XY. Plot XY. Awesome. Awesome. Great. Great. So we are doing very good, and everything seems to work. All right. These are only things I was worrying about. Now the second thing I'm wondering is, go to sessions. Change working directory. Okay. Choose. Now, do you have access to this folder?
That is a login user directory. He will have access. I have access.
Okay.
Each login user will have access to his own. So do you want some shared folder?
No. All I want is here in this folder, you should be able to create plain text file.
Exactly. See here, no. Here it shows form.
Yeah. So if you try to create an empty file here, are you able to? You will be able to create, right?
Yeah.
This is your Unix machine, right? This
Unix
one.
machine.
Okay.
If they create a file, it will be on their this path.
All right. Great. So that should do good for us. And then we'll see you on Tuesday, Wednesday.
What time?
Same time.
Let's make it at 9:30.
Yeah. Let's start at 9:30.
Yeah. Yeah. So today I reached 9:30, right?
Yeah. We were waiting for others, but
people
start.
should come after 10.